Hi, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project. So thank you for joining me this 27th of February 2022. I was probably going to want to spend another week on this presentation, and I lost most of the weekend and end of last week for interesting reasons. And anyway, my view is that if something was to happen, it would be better that I got something out there that I wanted to say rather than nothing at all. And I'll probably revisit this again and improve the presentation, but I want to put it out in a raw form. It is going to be bringing together a number of things that we've seen over the last several years and bring some new insights to the table, I hope. And I hope that it will be very clear by the end of this presentation that we have a tool to balance elements, to synthesize elements, and to convert them into light and leptons. And so, and for there to be a physical understanding and for this to be easy to replicate in terms of how it's actually doing it. So before I speak too much, have I got any double echo on my voice? Is there anything problematic with what I'm saying here? If I switch to other screens, is there any problem with that? Any problem with that? And just let me know, that would be great. Okay, great. Thanks, John Watson. So, hi, Daniel, Foster, Gordon, non-consensual of something. Hi, Duke Tree. Hi, DT105K. John Watson, well, I said you again. But anyway, hi, thank you very much. Hi, Wayne, for joining us. Right, good, excellent. Now, before we get into the meat of this, I want to talk about iodine 131. And iodine 131, if I've got that right from memory, is an isotope of iodine that comes out of fission reactions. In fact, it's about 3% of fission reactions. And when you have, for instance, a fusion bomb or a fission bomb, in both cases, they have a fissile material. In one case, it's in an M-bomb. It is actually most of the material that is fissile material. And in a fusion bomb, it's normally the percussion cap. It's the thing that compresses the fusion material in order to produce a reaction. Anyway, in both cases, you will get 3% of the fission material producing this iodine 131, which has about an 8-day half-life, and it goes into the thyroid glands around here. And so when it decays, it has two decay modes, which are both beta then followed by gamma. And both the beta and the gamma, in whichever path it takes, are high enough energy to cause genotoxic effects. That means it damages your DNA. And there's a way to protect yourself from this, and that is to get yourself some iodine supplements. And you can get those from health food stores. And you basically saturate the iodine that gets put into the thyroid glands, and that will prevent take-up of iodine 131 from the atmosphere. And you only need to do this for a number of periods of time, because it's this 8-day half-life. Very, very quickly the radiation drops below a level at which it is meaningful in terms of genotoxic effects. And if you're not into or can't get hold of this iodine supplement, you can actually get this. So if I just switch frames here, I'm just going to do something. Let's see if this works. You're wondering what I'm doing now. So I just want to ask anyone, have I got anything on my teeth? Have I got anything on my teeth? No? No? What I'm talking about here is seaweed, like this. And I have to thank John Hutchison for getting me onto seaweed. This is actually for making sushi. But seaweed actually has a wonderful capability. That's so good. A bit dry on the top of the mouth. It has a wonderful way of capturing iodine from seawater, and these are obviously designed to get out of the packet, not so easy to go back in. Now I have seaweed all over my desk. Anyway, the point is, if you can't get iodine supplements, you can go out and get yourself some seaweed snacks. And I thank John Hutchison for getting me onto the delicious flavours of seaweed snacks that you can get for consumption. Okay, now I have a fairly seaweed-free desk. I can proceed. Right. Okay. So what am I talking about with 369? And here's the title slide for the presentation today. And obviously those will have worked out that I have got this 3 on the side here, which we talked about, and I'm just going to run over a couple of the slides from last week's presentation. But I chose, and people might have wondered why I used omega rather than F for frequency, and really it was I wanted to use omega because this is angular frequency, and in fact actually everything that vibrates or has a movement in the universe actually also simultaneously has some vortical nature or spinning nature, because everything is moving around in spirals and circles. Even if it looks like it's going in a straight line, everything is going in some form of spiral or circle. It's very hard. In fact, you would have to know every relative moment in the entire universe in order to produce the sort of anti-version of that, in order to actually be able to travel in a straight line. But from everyone else's perspective, you'd still be traveling in a spiral. So I put frequency as the velocity there, rather. Am I right? That's the angular. Oh, I might have got that wrong. Anyway, this is the 3, and let me just check on that. Where I was on my slides last week. Just give me a second and I will pick that up. Yeah, so the slide that I'm referring to here, which people might have thought I was a bit odd in choosing omega for frequency, I was moving towards making a point. And in the case of this particular calculation, I was looking at the frequency here being 43 kilohertz. Okay, so that's what I was trying to get across there. Okay, so now back to today's thrust. So we have the angular frequency there, or the frequency term there in terms of omega, and you have to have this frequency first put out there into an environment before you get these yin-yang pairs forming. So essentially you have to put out that frequency, as it were, in order to create the yin-yang pair. So I wanted to say that a lot better, but I failed to. Okay, all right. So and what I have on this slide is images, an image from the takedown of the original Line 2 reactor, I think it was, and where we saw this jewel. And this jewel has been a huge fascination for me because of both its macrostructure and its substructures on it, and also because on this photo you see this 69 here, and this actually as a structure itself always fascinated me, and I wanted to think, you know, maybe that's just a circumstance, or maybe there's actually something to that. But I felt that, intuitively, I felt there was something to it. But there's also questions that I had about this dual structure. One that I've discussed greatly is that you had the heating solenoid outside and the reactor on the inside, and if it did produce excess heat, that means there was heat coming from the inside to the outside. But the bulk of the quartz was converted into this brown greeny thing, and I've discussed how that can occur and how it's used in gem processing, and even the rose color of the jewel itself, how that can occur. But what was absolutely bemusing to me, how there was this literally event horizon around the jewel, where everything around it was this particular green and muddy brown type thing. And inside the event horizon, there was this white patch on the inside, closest to the reactor, of a certain thickness. And then it just was completely changed in the way that it was completely different in the way that it was changed, this part of the jewel. And it wasn't an entire petal. It was kind of like half a petal, and then there was something that was a little bit wishy-washy on this side. And then it had this feature in the center, and I've shown how this aligns with many other structures that we've observed both in X-ray and so forth. But I wondered, it kind of suggests it would want a mirror, but why did we never see the mirror? And then the other thing is that it's actually not perpendicular. It actually goes out. It goes out, and this is interesting because it looks like the edges, if you were to project them inwards, would come to a focal point. So why is it doing that? What is this? Is this actually the whole structure a projection from something that was in the core of the reactor? And I think it was. I think you had a monopole or a monopole pair, possibly at the end of the iron bolt, a massive cluster, and it had potentially a magnetic or a something structure coming out that was, this is a projection of, and that was somehow shielding the effect of the quartz from whatever caused this to go green and brown, and it actually did something different to it. And we discussed that one of the ways that you create this rose quartz is you expose it to X-rays, or from like cobalt 60 or gamma rays or something like that. I've talked about it in the past. I think it's X-rays, and then it you then heat it to a certain number of hundreds of degrees, which this reactor was in excess of, and you would convert the clear quartz to this pinky color. In fact, it's the same kind of process or whatever that you do for this. So, but anyway, the point is that this was doing something, and I believe that there is a focal point into the center. Okay, so I talked about meditation and the fact that you had these vortical emissions from the fingertips of what Ken Shoulders says that's the fastest way to demonstrate to yourself that you can produce exotic vacuum objects, and I believe that they come out of here anyway, and I think that's probably the principle of Kirlian photography, and the fact that the sound itself helps to cohere the vortex structure and drive its increase in its intensity. And we talked about the Om and how the Om looked like it would fit into this particular structure, which we've seen on a couple of things in our experiments. But essentially you get this cardioid structure, which we'll talk more about. And I believe that this and this and this and this are all this kind of structure, and I'm going to show some more evidence of that, and also evidence of where I think the actual process is going on here, with the stuff coming out and going round and then coming on the other side and going round that way. Okay, so I had this presentation that I did about a year ago, or maybe more, people can probably tell me, where this was in the echo electrical discharge in water, and we got this spiral structure, which was kind of like a nickel spiral that came down and then produced a little cube or something at the bottom. This is in Vega, this spiral, and so these are two particular structures that I'd seen. But also there were these triangles, and these triangles have a very particular aspect. So I'm arguing that there is one of these monopole structures at the apex, like here on or above it in these triangles, and that is mashing up the material here and changing its nature into other elements, a range of other elements, and as it's being pulled into what you might call something like a singularity, but it's kind of not. And I believe that the reason this particular Hutchison sample that I have tore apart like it did here, presumably cold, and with these triangles, and the triangles are only present on the areas that tore, is that these are monopole structures, and they become so intense. If you have like a north facing a north, and it becomes more and more intense, sooner or later the metal is going to yield. The actual bonds are not strong enough for the intensity of the magnetic field. Obviously, within this triangular section, and this little triangular section here, the intensity is so much that it's pulling the material in and collapsing the material using the intense, in my view, potentially magnetic field. And interestingly, again, on the split plane of one of the Lion reactors, when you looked at the brown kind of quartz, there was these small triangles on that divided piece of quartz. Like, so if you can imagine, if you cracked a piece of glass, you wouldn't imagine that there is a triangular chunk, possibly with a radius like this, or how is that taken out of the middle of the quartz? It's like bizarre. So I suggested that this is again monopoles that are going on here. And I kind of had this insight actually before I saw some of those samples in that way, that there was a toroidal type structure, and this would be, let's say, a yin, and there would be a yang, which might have the poloidal rotation going in a different direction. So, sorry, the toroidal rotation is going this way, and you've got the poloidal rotation. So the poloidal rotation would go in the same way, but the toroidal rotation would rather than spiraling around this way, effectively going around this way, it would go around the other way. And so you would have effectively something that would be a north pole and something that would be a south pole, and it would create, a kind of shifting of material. Okay, so this is a soliton. Making a magnetic, pseudo-magnetic monopole, and this is very similar to the belief of many of the Russians that there are this kind of structure. This is 50% through it, and that this has a focal point somewhere here or whatever, and that this is the 50% cut through this kind of mushroom structure. And I've argued that this is effectively the lower part of the Ankh, and that the Egyptians believed from the loop down, this symbol represents the key to all hidden knowledge. And I discussed this in a presentation called Elixir Vitae or something, Water of Life. Anyway, this was from work from Perevozchikov, and this is kind of what I'm talking about when I'm talking about this. At the time I drew this, I hadn't seen this work, didn't know it existed, but many people have produced this particular observation. So this to me is a monopole type structure in flight, and this has been shown to be able to carry ions and effectively electrons, and possibly is condensed cold neutrinos. In fact, when Vladimir Zhigulov looked at this, there is kind of like and I think even Perevozchikov, there is kind of like a wave pattern in the top of this, and is that wave pattern related to the coherent nature and how it interacts with the film? I don't know, but it's something to think about. Okay, so I've drawn this sort of 50% cut through our ultra type experiments. And I hypothesized there was a soliton here and a soliton here, and in this case, you've got the outer part of the poloidal motion going around, and that kind of drags it in. We know that when it's rotating like this and it's going through air like a soliton from a smoke ring, it goes in this direction, and so it's pushing the material in, and I guess it forms this cone because the yield strength, or the ability of the metal to deform, it's limited at this point by the intensity of the energy that can be cohered, or something. For whatever reason, it gets this far. Now, is the dimple's a bit weird, because it's kind of like coming in, and it is this bit like we saw on the aluminium fracture sample of John Hutchison, where you have a bit that's just not affected in the middle because most of the material is moved or how should we put it, drawn, if in terms of metalworking terms. It's drawn where the maximum effect is of the vortex, and the fall off on the vortex is very, very intense as it's coming down. And so that's that, and then you have the mirror image here, and it's you know, the poloidal things going maybe the same way or the opposite way. I might not have mirrored that correctly, but anyway. And so you have this spiraling form here, and I looked at various samples. This is a 2007 sample. It's very large. This is about 4 centimeters across, and this is about 40 microns across. So it's several orders of magnitude, or a couple of orders of magnitude bigger on this right side one. But overall, the structure is largely identical. Unfortunately, we actually have the internal structure on this one, and it is conical. It is conical. And you can see this kind of circle type of spiral sections on this thing. It really does look vortical. And actually, when you overlay a distorted hexagon on here, it's the exact same distorted hexagon across several orders of magnitude that is occurring. And what I think this is the spiral coming down and then reaching this center bit. And I actually believe now that this is the same kind of thing that you get when you are looking at this, not this, that there is a spiral in here, a vortex, and this is something to do with this cone here. So you can imagine the monopole is somewhere in the core of the reactor here, and it's beaming out a cone which causes this to be affected differently. Either there are a lot of high energy beta particles coming out here, or it's literally doing something different to the matter. And you can see this is the cone in the material here when it's on the cut plane. So this is literally cutting the aluminium in half. So this monopole was actually just somewhere in the middle of the aluminium. And you can see that there's these cone type structures on a much bigger scale. Of course, if this is coming into a vortex here, is this the other part of the structure that's actually inside? So like this is the vortex coming down this side from the outside. It's coming from the outside. This is the vortex coming in here. So is it coming in here and then something comes out the other side, and one of these, I don't know, it's not entirely clear in this, but I do believe there's something very key in terms of the vortex structure and why it would occur. There's literally no way that I mean, just John gave me the ball burn sample, which is from 1986 or 1983 or whatever, 1986 I think. I've got it on a different slide later on. How he could machine this to have exactly the same distorted proportions and present this kind of vortical structure on it to something that he produced, 20 years later in a different metal, in this case aluminium, and it's right there. It's the same structure with the same distortion and so forth. And so this kind of implies to me that this is happening at the surface, and what you are kind of seeing is this vortex structure with the surface here. So here, and you've got, all you're seeing is the fact that this occurs on the surface and the vortex is working its way in, okay? And then maybe there's another one below the surface, so like maybe it depends which way you think about it. But anyway, I think there is a vortex pair in there somehow, or there's just one on the surface. In the case of this one, I think it's just kind of like in the core, and this is the beam that's coming out. Anyway, so what does this do? Well, in this, well, there's a number of things in this SEM, and so this actually here is the 40 microns. This is the structure that you've just been looking at, which we are looking at here under optical microscopy. This same structure is here under scanning electron microscopy, and this has the same structure as the on-video caught work at the Moscow Nuclear Physics Laboratory by Bogdanovich et al. So I believe that this is a vortical toroid, as they claim in their work, and that is the same kind of structure that caused this particular mark on the ball bone sample. But what I kind of want to go into a little bit more detail about is we're going to look at this one again, and we're going to look at this yin-yang pair. And so let me just find that. So this is the first of the two structures where you have something, a sphere or a hemisphere that's kind of looks like it's taken out of the core of this particular structure. And it has this, I think it's either a diamond or a quartz silicon and oxygen structure that's kind of somehow found its way into the core of this thing. And I argued in a previous presentation that this here, again another optical microscopy type image, was the same as this magnetic electromagnetic knot found in which they called a three-dimensional skyrmion here. And these are two sections from it, and these are effectively the same kind of mushrooms, and this is a coherent matter structure, and you can go and see it, this particular paper here. It's from just a few years back actually. And so you have this material getting sucked in here. Notice it's got this kind of cone area here, sorry, this sort of dome area here in this cone. This looks like the sort of soft effect here. So depending on the material you have, you get a soft or a hard effect. So aluminium is less yield strength, so you get a softer fall off. Iron and quartz is much more brittle, so it gives you a much harder defined zone. There's not so much strength to pull this bit into a cone. And I think probably here you're seeing it in a much more free environment. So you get a structure that is not so much the top of the lower part rather of the Ankh. You get you get something that's a little bit softer rather than flattened off. Okay, so those are the kind of structures. Now, how does this relate to sound? So I'm saying that basically you have to have frequency first, and that leads to the yin-yang. And I put it in the middle because the frequency is the persistence of the frequency allows for the yin-yang to continue to generate or allows them to be maintained. Let's put it like that. And so I did shared this video a year ago or more than a year ago, where there were some droplets of some compound. It's discussed in the previous video, I think, and it is injected using a syringe, and we'll look at that in a minute. But it produces, firstly, this cone shape from the outside of the sonicator here. So this is an ultrasonic horn with some probably PZT ultrasonic ceramic above that's excited. And this has a very flat surface, and this has a stiff metal surface here. And I was talking about this in Safe and Sound, the last week's presentation. And I believe that these droplets are forming on the nodes. Okay, so you've got the antinode here and the node here. So the node is where the maximum stillness is. But the interesting thing here is that it actually forms two spots. Why is that? I mean, you've got one spot here, but at the point where this cone comes together, and you'll see actually what's happening when we play this, it starts to, around this central point here, you get two spots. So like, it's actually forming either side of the focusing of the sound that comes down here, and then you've got the standing wave that's coming back up here, I guess. And so this is very interesting. But let's review again what happens when I play this video. So if I go forward, so the fluid is injected in, okay, and it produces these areas here, which are, I believe, on the nodes. And so you've got the antinodes in between. And it effectively levitates the fluid, okay? And if I move it forward, you can see that there is rotation going on. It's rotating, okay? So there is some spin, but also what you'll notice is that the standing waves are across the whole width, almost all the way down, if I move it forward a little bit forward, okay? But very rapidly, they're moving around in a bulk vortex. So you can imagine the whole yin-yang structure sucking stuff in from the galaxial plane, and it's pulling it in. And we discussed this before. There seems to be a yin and a yang. There seems to be something that likes to grab the material. And this actually could be a very easy experiment to replicate. Okay, and in fact, it does, at the point of convergence is where it's quite the first most stable spot. You can still see there's some instability here. And as we move forward. So at this point, you can see that the one behind is kind of like often the one that has, you can still see it's kind of there. But it's kind of like, it's a grey version of the one on the left, which is much brighter, which, because there's a side light, maybe that's an effect. So that maybe this is partially in shadow, and maybe that is an actual reason for that. And maybe they are fairly similar in terms of density. Here you can see that they look very similar. So the kind of shadow argument doesn't quite fall well with this. You have 4 here that they actually eventually converge. And so I would like to see some people replicate this type of experiment with better photography and so forth. In fact, up there was a bunch of 4 of them, and they explode, and then they sort of drop the material lower down, and it has to sort itself out. Okay, so I wanted to show this last week, but it's just as well to do it this week. So here you can see there's some material here, and watch what it does. Oh, if I can actually get there. I've messed that up now. And I talked about this the last time I talked about it. It kind of actually, it orbits around and comes into the backside preferentially, it would seem. Okay, so you can see by here that there are these very distinct 2 spots, but there seems to be something connecting them, and we're going to probably see something similar. Okay, so I had this image from Martin Lammers in Holland, so thank you very much for his ultra experiment replication. I actually have some of the videos that this was taken from, different sections of it. So you can see here the sound pulses coming from the ultrasonic horn. It looks like it's causing a bit of vortex around the outside of the horn. Okay, and similarly, if I could actually move this, and you can see it here better, there is also a conical formation of nanobubbles from the outside of the horn in this instance. So the previous one was in air with a sort of easy vaporized fluid. This is actually in water, and we are witnessing the conical structure forming out of the nanobubbles. But here you can see something spinning around a central point here. So I would believe that something similar is going on here to what we saw in the horizontal column of the previous slide. But this is something to do with the edge of this sonicator, and maybe something that's reflecting it up here, I don't know, or maybe the side here and the wall of the vessel that Martin Lammers has got this in. Okay, and then there's another video here, which is the lead-up video. The problem is with this video, it's got a phone camera that is interpolating frames using AI. So every other frame or every number of frames is a complete guess at what's going on. But anyway, within this particular structure, you can see several of the structures that were claimed by Solin to be the basis for quantum coherent nuclear reactors. Okay, and again, you've got the same kind of pulsating going on here. And you can see that as the pressure changes, so I imagine what's happening is as it pulls back up, as the sonicator pulls back up, it produces a lower pressure in the difficult to compress water column, and that causes the nanobubbles that are within the water to present themselves, which then reflect the light. And so that might be what's going on there. Okay. So this whole thing of being above and below the plane, of possibly this being above and below the plane, has given me some other insight into what might have been going on in some other things that we've seen. So this was from 2016, and this was in Hungary, and it was actually, I did a series of videos on which I called Stardust from my early meetings with one of the world's greatest experts in ball lightning, Dr. George Eagley. And this was on the about an hour's drive from Hungary. In this, sadly, the guy died that actually made the nova and supernova reactors. He actually died from cancer, so he was 40, which is a terrible disaster. And it's something why it's taken me some time. I wanted to really understand what was going on before I put my own children at risk of becoming fatherless. Anyway, this mark on the wall here was said to be from a previous experiment. Certainly this wasn't caused during the experiment that we ran, but Dr. George Eagley said it was caused by ball lightning. And the interesting thing is, it looks exactly like it is this structure that we see everywhere else, where you have one big spot and one small spot, one big spot, one small spot. What are we looking at? Well, this would be the side of the yin-yang pair that is in front of this one. So you're seeing the effect of the one that's behind over here. Or maybe this has moved ahead of this one and behind, and it got stuck for some reason. And anyway, the point is that one is in front of the other, which produces this structure. From this particular experiment, so by the way, this is ball lightning, and we have a structure that has two blobs, and they are these kind of ratios. We're going to see something a little bit later on, let's go forward. Okay, so what was produced in that experiment, we separated out some magnetic particles, and these are they, and one spectrum one here was high in silicon. You can see 17.3% here, and one could argue because of the silicon and oxygen here, the silicon SiO2 could be glass that's come from the wall of the fused quartz chamber that it's in. In fact, I'm going to get one from next door and I'll show you what I'm talking about. And before anyone asks, I didn't get this free from some sort of social program. This is actually a piece of fused quartz. This is not borosilicate glass, and so this would melt at 1,700 degrees C, and again with this tube. And so this is what we put some crushed charcoal in. Charcoal's good because it's got potassium 40 in it, and so that can enhance the process. And then you have what I've learned in the last several months is the importance of sound, and I'm going to be applying this to this experiment, and I'm so glad that I have very limited glass, and the guy that made this may not even be alive. He was very old, and what I want to do is get my ultrasonic mic and hang it from a thread and ping it. And hear what sound it comes back. If you remember my 2012, 13, 14, maybe 2012 video, I think it was, where I said, you know, you got a Tibetan singing bowl, you have to bing it and you get the resonant sound coming back, or you gently caress it. So there's two things that I will do. And I've actually not tried this. I was thinking about this in my head. So if I ping it, then what I have is I actually have a frequency input to the supernova reactor, and what I will do is the frequency will change, But what I want to do is create ion acoustic waves across the spherical section in here, and also consider ones that might work down the length of it with a bung in the end. And depending on the temperature, the speed of sound in there will change. But this does provide opportunity, because of its spherical nature, for resonance and phase conjugation. So that this will produce a wide array of standing waves in there, and I believe the standing waves are where the nuclear reactions will take place. The other thing I will do is do this. So I'm blowing that like a flute, and so I already have one of my resonant frequencies there, which is this up here. So you could probably play back that recording. Sorry for your ears. And that would be one of the frequencies I would like to test, this long frequency in here. And then there would be other frequency that I would like to do, which is the ping that I would get back. Maybe my finger's going to attenuate this too much. I've got it on here, but I'm going to hold it up against the microphone here. No, I'm not getting it, because I need to suspend it with something that's not going to damp the resonant frequency when I ping it. But anyway, so if I had done this experiment 2 years ago, I would have basically wasted the glass and lost the major opportunity. So I learnt a phrase from a very good programmer once, which was measure twice and cut once. And also I think I heard the same phrase from a carpenter friend of mine a long time ago. Anyway, so this particular experiment that you can go and see in those videos from 2016, there was this 2017 rather, there was these iron crenellated iron oxide spheres produced, okay, and you can see here with this large spectrum 2 area here, which is in red, that you have O is 31.1% and iron is 51.5%, so it's extremely high concentration of iron. And so this was the first time that I saw a bunch of iron-rich crenellated spheres. The interesting thing is they kind of aligned themselves up in this line. So I think there's a north-south pole here, maybe, I don't know. But you can see how they are magnetically attaching to each other. And we've seen this in the Lion reactor and in other experiments as well. So these particles were genuinely magnetic in the ferromagnetic sense. But under the SEM, I noticed something very odd. Both of them, both the big sphere and the little sphere here, the second largest sphere in this plane, they had these pits. And in the eye of one of these spheres, there was nearly a pure carbon blob. And you can see that this is a hole. This one's kind of like a hole, and on this side, it's kind of like a blob. Or it's certainly the internal area, but to me it looks more like a blob that's coming out, because you actually have a shadow from the side that the electron beam is coming from. So the electron beam is coming from the bottom left. You can see that because you've got the green here with like a crescent of that, and that is the shadow. That is the shadow, or if this was the moon, this would be the shadow on the moon, and so you don't see it. So this means the electron beam is coming from over here. If you put that down to where the carbon is, the electron beam's coming over here, and it's casting a shadow over here. So this looks like this is prone, okay? And this looks like it's a hole because you have a massive shadow here. So whilst you can see it here on the secondary electrons, you've actually got the this being dark. So this is a hole. Now, I thought if this was kind of some sort of flux loop on here, why would this be spherical? And it had me taxed for an incredibly long time. And then again on here, if we've got these two features on here, why, if this is a flux loop, why is it? I just couldn't make any sense. But if you imagine that you have two, a yin and a yang, you have a north and a south pole, then and the material, somehow the material is cohering in here to produce a lot of iron and oxygen from the whatever is in the reactor. And potentially synthesizing it, then when it comes back into our three-dimensional space, and I've talked about this before in respect of this particular image, that the iron and the oxygen, which has lost all of their electrons, when they come back into our three-dimensional space, they do that by gaining electrons and reassuming their full atomic size and forming a big blob of iron, in this case a pretty spherical blob of iron. And so the actual cohering structures that caused it would be much smaller potentially than the actual blob of iron that appears after the coherence collapses. And again, that's the same here. The interesting thing is that the center point between these two is also the center point. The center point between these two is the center point of the sphere. And the same is the case with here. The center point between these two is the center point of the sphere. But of course, you could just rotate that round, and you would have a different viewpoint on that. But anyway, those are my considerations there. Okay. So in this case, we are looking at another part of the ball burn. And just to clarify here, Yul Brown said that when he transmuted material, it mostly ends up as carbon. So I think he was the first person to cite that. I think it was in his 1980s patent. But he also talked about it, that there was a newspaper article, and I've referred to this in other presentations, that it was forming carbon. And so this was the first thing that I experienced, actually before I learned of the observations of Yul Brown. This was the first thing where I saw a particular structure that seemed to be synthesizing carbon. Well, this is the yin-yang on the ball burn sample from the 1980s. I think it's 1986, from John Hutchison. And note that it has two structures which are essentially identical shapes, but one is basically a big hole, and you'll see that in the next slide, and I've shown that before. And they intersect, so they're partly overlapping in a very similar way to our yin-yangs on our ultra experiments. But this is also manipulated, it's damaged in a way, but only within this incredibly tight event horizon. So on this side, the steel is completely removed, and then it's not removed at all. This is essentially as flat as the original sample is, and then it's completely removed here. And then on this side, it's affected, but there's, again, a very small fall-off. The actual fall-off here is more marked than it is here, and I believe it's because material is coming out of here and it's slapping down on here, or rather it's sucking material out of here, and something is going on in here. Okay, anyway, let's look at what we have there. This is the structure taken with macro photography, and this is scalloped out. This is actually kind of like a sphere, that's a hemisphere type structure that's scooped out on the one side. And when you look at it on this side, which is sample 55, you can see that the carbon is 47%. The iron is 26. This is by weight. So you got the iron is 26.8%, and the oxygen is 12.2%, and you have some nickel there as well, and chromium. But the interesting thing here is, obviously, there is some carbon that's, I believe, has come from here and slapped down on there. And you can physically see here the carbon spots in here. The carbon is not there in the same way on the surface of the unaffected steel surrounding this area. But there is clearly, in these crevices, there are blobs, and they look like spherules, actually. And they could be self-similar structures of the overall structure, and we've seen that in other experiments as well. So here we see some carbon, which I believe has been born here because the material here has been disassembled. It has been disassembled, okay? Where are we? So if we look on the spectrum 56 over here, this one is 65% carbon. So it's like 20% more roughly in terms of carbon. But look at the iron in here. It's just 5.8%. It's just 5.8%. So my view is that the iron that was scooped out from here was converted to largely carbon and other elements, but largely carbon. And some of it came down and slapped on here, and maybe some of it bounced off. during the course of this structure doing its business. Now, on this other slide here, this is actually from, I think, 1996. We've got maybe a date down here. No, not on this slide. But anyway, this is a lead ball. And out of one of the poles of this lead ball, you have the plume of carbon. And this is from Matsumoto. So I believe what's going on in here is something similar to what's going on in here. And it is this disintegration of matter, and I think the same thing is what's going on in here. This disintegration of matter, and because it's iron and it's being converted into carbon or whatever it was that was going around here, and when it comes down here, this is the disintegration of matter on this side, and it slaps the carbon down there. Okay, if it's actually a ball. One to the other, but one is making and one is breaking. Okay, this is definitely eating the material away. You can clearly see it's eating the material away here. Now, this sphere here, I wonder if this sphere is, in my drawing, the sphere here being assembled, but out of the pole, which would be, let's say, the North Pole, it's stripping material out. So as material comes in and coheres into the magnetic center, from one pole you get some of it coming out and being disintegrating, as it were. And so is that what's going on here? These are questions that I'm asking as much as statements. Is that what's going on here? Lead obviously is 204, 206, 207, 208 nucleons, and carbon is 12 or 13 typically, without including the radioactive carbon 14. So you can get a lot of carbon 12 out of lead 208. Let's put it like that. Okay, and here's another image just for the sake of argument, where there is this one side, and you can see how this fans out. It's not a straight line. It's straight at this point, but it's not straight at this point. And this point is the center line. Now, was there another structure on this side? I don't think there was. And if there was, did it go all the way through? No, it didn't. So was this the one that was in front of? I don't know. And the same structures, if we looked at the side of this jewel, this is the edge of the jewel. So this is like looking at this edge or looking at this edge. You can actually see that this is made up of substructures that are the same as this bigger structure. So it's actually covered in yin-yang pairs in a smaller sense to the bulk structure, and the same kind of scale of yin-yang structures are on the side of the MFMP Hutchison fracture sample here, and I've shared this before. Okay, so these are, in my view, the magnetic north and south structures. Take your pick. And one is above the plane and one is below the plane. One is in front, one is behind. And, you know, this leads me to this discussion of 369. And there's this famous kind of image of vortex math. You know what? I don't need to repeat everything. There are videos out there that have been viewed millions of times. And, you know, Tesla says, if you only knew the magnificence of the 369, then you would have the key to the universe. So I'm suggesting something different, and I'll give another waypoint on that. That the angular frequency here is the sound, or whatever it is, the vibration that is causing some rotating effects that are causing some focusing, but some division around on the standing wave node, because there is a vortex surrounding that structure, and that leads to some kind of way of charge separation, which leads to kind of these yin-yang pairs, which I believe have this structure from the hydrodynamic, which is actually magnetohydrodynamic in ultra experiments, and you get something around this center point here. Now, this is from bang up-to-date work. I think this is from 26th of July 2020, and you can see this kind of infinity shape here, and this is working around a cardioid. So I mentioned cardioid before, and why? Well, we've seen this kind of cardioid structure many times. You can go and have a look at this wonderful chap talking about how cardioids occur. And this is where you have a light source on this side and you have a reflective thing. And this is I used to do this in my 3D animation. It's a Fresnel reflection. So it's where the light rays bounce and so on. You end up with the cardioid shape. And obviously light in a teacup does this very, very quickly. But I've shared this cardioid structure from a range of experiments. So this again is a cardioid structure with the two spots in the center, and this it's weird because it's slightly offset, the cardioids. Actually, they tend to be slightly offset. And so this is on the jewel. So again, this is on that same jewel that I have here on this surface. So this cardioid actually is about at this point over here. So so it's a cardioid on part of the, it's a self-similar structure going on. So that's on that lion jewel. This is in an ultra experiment with our cardioid here. This is in the Parkhomov 225-day reactor, the 7-month reactor, which produced this cardioid. And we're going to take a look at this in much greater detail. This is on the palladium-coated a Marsa vibrator plate where we saw diamond in the middle and helical arms like a spiral galaxy coming out of this with double diamond, i.e. magnesium, and then outside that you had quad diamond, i.e. chromium, in a vortical structure coming into the center of this. And because it's carbon in the center and coming out and becoming heavier and heavier elements, I would suggest that that is possibly the North Pole again. So the carbon is synthesized from the palladium or from the steel underneath or from the material that's captured in the environment and passed through the other pole. And then it forms the carbon, but as the pressure gets increased or the decreased or whatever's going on with these vortical structures that are coming out, you get this sort of pressure gradient or some kind of pressure gradient change in the synthesis of the elements that are coming out. And this is from Tom Claytor, who is a former Los Alamos National Laboratory researcher, and Roger Stringham, who has been doing sound-driven transmutation experiments for the best part of 30 years plus. And you can see this spot, which is actually only about 50 microns across in the center, is a cardioid structure. And actually, this is a metal plate, and it has, parallel to the plate, a transducer, sound transducer, which is going through, let's say, deuterium, or heavy water rather, or light water. I think in this case it might have been heavy water. And at the focal point, the sum of all sums, it has this structure. Now, was it at the focal point, or was it just at a standing wave node? Well, if I was to do this experiment, I would try and find out the speed of sound through our water, which we worked out was about 1,430 meters a second in our previous experiment, and I would put this metal plate at the node of the experiment. Now, we've already shown in ultra experiments that it tends to move itself to the node of the sound from the ultrasonic transducer in the water all by itself, because the aluminium foil is flexible. And actually, this is underneath this thing that was on top. It basically grew on top. And you can see that this is the same scale here, but this is 100 microns, so this is like 200 microns across, okay? And so, and this was a whole range of elements synthesized. So from this cardioid-shaped structure, there was a range of synthesized elements. From this cardioid structure, there was a range of synthesized elements. And from this structure, we will see something as we move forward. Okay. So here is our cardioid structure on the 225-day reactor from Alexander Parkhomov. And there's something extremely significant in here, which I hope I'm going to be able to get across. And I think it's a major, major breakthrough in understanding. And you can see it in several systems, okay? And it shows the relationship, because I was always trying to work out whether this was a 3D structure or it's a planar structure, but I think we now know that it is offset planar, like the two magnets that I was showing in a previous experiment. And you can see these two bands, and we've seen these kind of two bands or multiple parts of the vortex going in. We've seen this in the ultrasonic slow motion photography, or high speed photography rather, slowed down from ultra experiments. But it is a very distinct cardioid. And the interesting thing is that this wouldn't have what you would call sound, but it has vibration, because it's got temperature, which is vibration. And so you're going to have resonant modes of that. You're also going to have maybe 50 hertz, kind of like in the environment, either from the solenoid being heated or whatever, if it's directly heated by the mains and it's just a change of the voltage or whatever. You're going to get some oscillation going on, which could set up some vibrational modes in even just in EM modes through like changed in the system such that you get vibration. And I believe that probably something like that was going on here that led to this being formed, because all matter vibrates, and thermal vibration is vibration, and sound vibration is vibration. And so it doesn't matter what you are doing, you are always getting vibration. Now the interesting thing was, and I have to kind of think this is, it's kind of like whatever happens, I have to accept that there's probably a reason for it. And when I had this particular sample in the SEM, I've described this before, I thought, wow, this is an amazing 3D structure. And it's actually swept up these silicon, whatever it is, this particular felt that he had put in, and it swept it up into this structure. And what it appeared to be is it responded to the electron beam from the scanning electron microscope, because when I sent the electron beam to it too much, it actually flipped over. It flipped over and showed me its reverse side. And on its reverse side, on one side, it has a sphere on this side, which would be down here. Now, if I click, maybe I've got it on the next slide. No, I haven't got it on the next slide. Have I got the slides in the wrong order? Let me just check. Oh yes, I've got the slides in the wrong order. This one should be here. Okay. Okay. So here, what I've done is I've taken this circle around this sphere structure that's here. Okay. And I flipped it over here. So this is flipped over here. This is flipped this side. So in this area, it has this circle. Now, to me, that would imply that this is the lower structure and that this is the upper structure. And do we have any other evidence for that? Well, if I go to the next slide here, this is actually the first SEM that I captured this on. And you can see the structure up here. And this is when I wasn't trying to get it into frame. This was like, I took this frame to see, if there was anything interesting from the core of the 225-day reactor, the sample that I'd been given, and I thought, what's that? What's that? The cardioid structure, what's that? And so I did a map on this, and you can see it here with the different elements here. I've not got all of the elements here, but anyway, this is the bulk of the elements. So we can see the edges here and this central section here, and when we highlight it here, we can see that this ridge comes round here, and then this, from the center of this part here, or roughly the center, comes down here. This is the silicon. It comes down here, round here. So this is going underneath, and that's the circle on this side, and this is the circle on this side, but it's kind of coming from the center. Now, if we move forward a bit, and we come to here, it's maybe clearer on the oxygen. So you've got the ring here, and that goes kind of underneath. And again, it's the electron beam is coming from the side over here. And so it's highlighting the wall of this part of the cardioid, and it's highlighting the wall of this part of the cardioid. But there's something like, it almost like goes into the center here, okay? If I move forward, what else have we got? Okay, so we've got the carbon here. So in the carbon structure, we can see this band of the carbon, this band of the carbon, and then there's a dark area here, and then the thing coming out of the top. Okay, so from my view, when I look at this, it looks like that whilst this is, how shall we put it? This goes underneath this area here. This bit is on top of it. So this would be, let's say, the one on top. And anyway, the point is one is on top of the other. And I can go in and you can see that this is again 200 microns across for this structure. You could imagine that the bit in the middle that's doing all the work is smaller. And I've got the structures highlighted there differently. So it's a little less fuzzy because of the little more fuzzy because of the lack of resolution here. So anyway, I believe one is on top and the other one's below. Now, if we look at the reverse side of that, most of this fluffy material is carbon, oxygen, and a little bit of nickel. But this spherical blob here actually has calcium in it. It has calcium in it. And this is on one side of the structure. And you know, I've seen that before. Where did I see it before? I saw it in this slightly offset triangle where on the outside of the Lion 1 crust. And so you have this slightly offset triangle, which I believe is either the yin or the yang, but because you've got material. Now, is this material coming out or is it going in? I believe it's going in, and I've said this before, that I think it's punched this cap of material through, revealing a hole below. So was the hole cut out and materials going around in a flux flow and then this is coming out of the hole, or is this going into the hole? It's still an open question in my mind, but definitely there is this triangle structure. Now this structure that's going in, the surface top here just has copper and oxygen. This is copper oxide. Given the ratio, it's mostly CuO. All right. This thing here is 6.4% calcium. Okay. And you know, where's that coming from? And we've got this structure here is calcium. Now, the interesting thing about the Parkhomov 225-day reactor, parts of the ceramic only had less than or around about 1% of calcium before the experiment commenced. And after the experiment concluded, it had nearly 20% calcium. Now, this is one potential way that the calcium could have been synthesized using these structures. Or it could be synthesized by the tungsten interacting with these structures. Now, we've shown on a Mars gas treated tungsten that every little sphere has calcium in it. And the most likely fission reaction, so tungsten to two elements, is calcium and xenon. So in both directions, you've got, in this view, I think the calcium is actually synthesized by the fusion of carbon and oxygen, which there is abundance in here. It goes to silicon. There's also silicon in here to start with anyway. And then if you get the silicon and carbon fusing together, you end up with calcium. So this is fusion, but I think the bulk of actual calcium production in his reactor came from fission, or the same structures doing what I will argue is a balancing act. It's a massive balancing act. If there's light nuclei and heavy nuclei, it tries to find somewhere in the middle. If there's only light nuclei and you're pushing it harder and harder and harder, it will try and find a range of elements, and it'll balance the energy input with an outcome, and it'll kind of reach a threshold. If you push it harder, you'll get a higher threshold. So like if you do ultrasonic experiments and you don't push it too hard and your elements are light to begin with, you're not going to get too heavy elements. But if you do what Leclerc did with the aluminium foil with the punch holes through it, you end up producing transuranics and causing a lot of radiation in the traditional sense. So depending on how far you push it, the system is always trying to find balance. It's trying to make and break. It's trying to destroy and reassemble. It's trying to electronuclear collapse, and it's trying to electronuclear regeneration in the parlance of Takaaki Matsumoto. Okay, so I believe that's what we're seeing here. I believe this is the same process that's going on here. And now I'm going to show you some PSDs. And so you give me a second here, because this should have been in the presentation, but I wasn't going to hold you out any longer. Okay, so we will go to Photoshop here, and I will come here, and I'll go like this. All right. Okay, so we have our 369 here. Okay, and I'm going to show a bunch of stuff here. So the first one is the overlay of our double structure here. So within this zone, you have one-handed rotation, and within this zone, you have the other-handed rotation. And as you go round 1, 2, 4, it might be I've got the rotation wrong in this case, but if you go round one way, if you're going round this way to one, that's going round that way, and if you come round this way, if you go round in a direction, the actual vortex in here goes in the opposite direction. So go round that way. Well, what is it? Like down there, up there, round there, down there. And it's going around the other way. You can see see the point I'm making. I'm no expert on vortex images, but anyway, a lot of people talk about this from a mass point of view, and I want to show how it actually looks like it has direct physical manifestation here. So I'm going to show now the structure here. So again, you have your cardioid here, and if you can imagine, the light is beaming from 9. Okay, the light is beaming from 9. Light being unassembled matter, and it comes down and it bounces round here. You will end up with your cardioid shape. Okay, so unassembled matter coming from point 9 in the form of light ends up forming a cardioid. And the structure that's doing it is the yin-yang. Okay, and something is coming out of the center here. Okay, something is coming out of the center here. That is what I believe is going on here. Something is coming out of the center here. So it comes from the center here, goes round, and then it comes out of the center and down round here, and goes round, and comes through the bottom of the center here and comes round like that. So you can kind of see it here. If I get rid of that. This is what I mean. This bit is on top, and it's going into the center here. Okay, comes round here, maybe into there, and then goes from the center there and comes round there and like that. Okay. Here is the Amasa gas on the tungsten. Okay, and this is actually quite striking, because in this dead zone in the center here, in this literally the dead zone, you have a hole. We have a hole in that 0 point there, that 0 point crossing point there. Okay, and the kind of center of this vortex is roughly slightly off the center here, and again here the center of this vortex is slightly off the center here. Not too dissimilar to what you see. If I can get rid of the other images here, slightly off to the center. I believe it's slightly off to the center, but maybe it kind of depends, I guess, on the intensity of the process. Okay, so that is the tungsten. Now, the other interesting thing is, I have said that at this point up here, it appears to be disassembling matter. And what you see is carbon coming out here, right? So not only have you got this carbon being, you've got, how should we put this? You've got breaking on one side and making on the other, and it's kind of like a virtuous cycle between the two until balance is reached. And you've got a range of elements here. I think the sphere in this one is here, and we've analysed this in other videos, and there's a good selection of elements synthesized in this structure. Okay, this sphere at the point 9 here, it's like something and is causing the matter to disintegrate, and you get this film of carbon here. So is this intense, like kind of side vortex here, producing a beam that comes down and it disassembles matter, or rather it strips matter apart. But if it hasn't got anything to strip apart, it just pulls in any boson, right? So the carbon-12 is a boson, but light could be a boson, and sound could be a boson. Anything coming from here could be a boson, right? Anything that is a boson could come down here and be cohered. So the sound energy could be cohered, the light energy could be cohered, and the matter could be disintegrated up here. It falls apart because it's depressurizing the environment over here to such an extent, in my view, that it's causing the matter to literally fall apart. And it comes down here, and you've got to make and break over here. So this is the same structure, I believe, which we had for the Om symbol. So this is the Om symbol, rotated. This is the Om symbol. And again, you get this two-sided structure, and above by the 9, and in this case, it's got plenty of water that can come in. So the water can come in, and it doesn't get, it's not affecting the aluminium up here. I mean, there's a vortical kind of effect here, because I think there is as this spins round from one to the other, it produces a kind of vortex that comes out down this semi-center line. It tends to be slightly offset. It tends to be slightly offset, and maybe it's kind of offset the other way on the other side. But anyway, it tends to be offset. So material in this zone up here, and you can see how, this zone here is this side of the vortex, this is the other side of the vortex. You've got the central dead zone here, and then this whole area up here in this kind of between the 1,8 and the 9 and down to the 0 is this area where it's kind of like grabbing material. And then, so this is on an ultra experiment. This is on the a Mars gas on tungsten. This is in the 225-day reactor of Alexander Parkhomov. And this is a Mars gas on copper, on the 10 yen coin. And if you remember, this side is where we had the ball, the spheres, producing the sulfur from the oxide on the copper. Okay, so I don't know whether this is this way round or it is this way round, but I'm sure it's one of the two. Okay, so if I go here and I grab this layer and I go like that, is it this way round? Like, is it meant to be kind of like something like this? Okay, is it like that? Is this our cardioid here? Okay, and this is our dead zone, and up here is the disintegration area. This kind of looks like the disintegration area, so it's one of the two. But there are a range of things here, and I would say that either the disintegration area is down here or the disintegration area is up here, and it's just kind of pulling plasma in, and it's assembling matter and doing stuff there. So this is literally it is the oh God, I have to say, it's like the Masons. It's just like the Masons. Out of chaos comes order, and vice versa. It's black and white. It is the yin and the yang. Unfortunately, we live in this universe, which is creative destruction. And how can you find harmony? Well, you have to find balance. You have to find balance with the environment. You have to find balance with your peers. You have to find balance with every single aspect of the universe. You must work with nature. It's kind of my old kind of belief structure behind Homo symbion. You have to move from being Homo sapien to Homo symbion. You have to work, man working with the planet and nature, because nature will rebel, and humans are nature as well. We're part of nature, so you can't push even the human system too far. Otherwise, the overall nature will find a way of getting things back into balance. It just will. And it will be irresistible. And it may manifest itself in so many different ways. People say, like, if God is supposed to be good, well, how can he do such evil things, particularly in the Old Testament? And it's kind of like, well, is he trying to find balance? Is he trying balance? Is that the truth? Is that the truth? I don't know. I mean, I'm just musing here, but these are the structures you see, and here is a cardioid structure here from a website that I'll give the link to. There's an excellent website that does all of these kind of structures. So this is the cardioid. You kind of get this down here, and this is where light comes from. Now, there is a school of thought, and I do subscribe to it, that light is vibration in the ether, and that matter comes from assembled light. And you only need to look at the fact that if you get an electron and a positron and they collide into each other, they annihilate each other. One is antimatter of the other. The positron is the antimatter of the electron. They annihilate each other, and what you get out is two photons. Two 511 keV or whatever it is, 600, whatever it is, it's the energy of the mass of the electron. So it converts two electrons to two electron mass leptons, charged leptons, one positive, one negative, to two photons, okay, of equal energies. Okay, so I've argued that, possibly a solar panel is actually synthesizing an electron from the incoming photon, or from at least part of its energy, rather than it being knocked out, which is the traditional assumption. The electron is being knocked out. Is it actually that, or is it actually being assembled by the band gap or whatever? People can work that out. I'm not going into that too much now. But anyway, the point is if two charged leptons, one being matter and the other one being antimatter, interact, they produce two photons of equal energy. And is that what is happening here? What it seems to be observed is that you can synthesize matter, okay? And to a certain extent you can destroy matter. So if one side is disassembling matter to a too intense degree, it will actually end up by completely collapsing the matter. Does this get faster and faster and more intense and then collapse into the center point, and then the matter is completely destroyed? I don't know, but I think we do have an answer here somewhere in what we are looking into now. So let's see where I want to go with this in the next slides. Okay, so are there any questions at this stage before I go on to my last notes here today, my last slides that I want to share, which are quite a few actually, by the way. Not as much as I wanted to share, but okay. Okay. All right, well, if you want to drop some questions in, I don't see any. You're having a great discussion amongst yourselves, and I like that. That's fantastic too. Yes, Dan Moretti, the Masonic logo with the right angle tool, whatever that's called, it's pretty reminiscent. Yeah, a lot of people have made that correlation between the two systems, and I believe that is absolutely 100% correct. It's 100% correct. There are people that either know this technology or have worked it out, or I believe it's been passed down. And I actually believe it's been passed down through masonry. Literally, it's been passed down through masonry. Okay, so right. I mean, I don't know if you can grasp the significance of what I'm attempting to share here, but it is literally all there is. It's all there is. It is the great power. And we have to respect it. But even in understanding it, it actually teaches us what we must do. We must work and find balance. Now, there is a potential for us to use this technology to find balance and become what I would call more Homo symbion and not Homo sapien. But it has this terrible, terrible dark side, unimaginable dark side. Okay, all right, I'm going to go on because we've got quite a bit to get through. Okay. So I'm going to introduce something here which I'm going to suggest is actually potentially what Tesla really meant. I know there's a relationship with the 369 on this vortex math, but sometimes people hide extra meaning within something than what is the more obvious of the meanings. And Tesla was a bit quirky, and one of those most significant quirks that are talked about is that apparently Tesla would walk 3 times around the block before entering the building. 3 times. And 3 is an important number. And we have seen it in our experiments over and over again. But is the 3 this 3 on its side, which I suggested, but I know that's just a kind of visual thing and so on, but angular frequency, well, you know, when Tesla is walking around a building 3 times, he's going around it 3 times, but he's going round it 3 times. It's angular frequency. Was he trying to suggest something? He was trying to make a quirk that everyone would be forced to know was his quirk, but without having first the angular frequency, you don't end up with the 69. You just don't end up with it. You have to first have the 3. You first have the angular frequency, the going around a building 3 times, right? You have to do that, and that leads to the 69. So 3 comes first, although it's and you need to have the angular frequency going on and going on and going on to keep the 69 making and breaking, which was the title of my first realization presentation back in March 2017. Make and break, make and break, collapse and rebirth, regeneration. Okay. The other thing is I like this so-called Nikola Tesla holding in his hands ball of flame. This is a famous image. It's on Wikimedia Commons. And I like the fact that he is left-handed and right-handed. Left-handed and right-handed. And you look at the structure, you've got the cohering vortex between his legs. You know, anyway, I can't help thinking that this isn't the same thing. Yes, Daniel Forrest, you're going to see Trinity. But anyway, the other thing is that in this image, he also has double there. There is a intense glow in the middle, but there is a fall off on the outside. Okay. Now he could have some vacuum thing in there and have an element that's touching his hands, and this is kind of like metaphorical, but it's actually some form of single-ended light bulb when he's attached to some electrode. I don't know. But this is left-handed and right-handed, or from our perspective, it's that is right-handed rotation, and that's left-handed rotation. He's effectively doing what I was talking about, kind of like here. This is it. He's doing the same thing. I don't think that this image is anything other than showing the future that he had a deep understanding. Okay? And of course, the face itself is the left hand and the right hand, or in this case, this is the left hand and the right hand, and it comes down, and the thing that takes everything into your body is your mouth. That is your ingesting point. That is your ingesting point. In these images here, the ingesting point is the 9, but your eyes are here and here. And one is a left rotation and one is a right rotation. That is where your eyes are. Your eyes are here. This is your mouth. Okay? This is your mouth. The food goes in the mouth. We are made in the image of this structure which persists throughout all nature. A literal face. Our face is made in the image of this This thing that makes and breaks, keeps balance, synthesizes matter and returns matter to light and leptons. So here's another image, and I'm just going to put some random slides in here and just talk around them. This is something I shared a long time ago. So this is from line 2. And I noticed this very weird thing that on the cut plane, which was kind of semi-incident with the end of the iron bolt, there were these scalloped sections, okay? And the reactor never went above 1,500 degrees in terms of its capability from resistive heating. It may have gone higher otherwise. But the scallop sections weren't just a perfect curves, and this is the outside curve, and this is the outside curve of the original diameter of the tube here. This is alumina, so this melts at 2,100 degrees centigrade. So this didn't melt, and it was perfectly cut. It was literally cut with an event horizon, which is very, very, very defined. Very defined. And it's not just cut in this aspect. If this is the end on, but if you went perpendicular down the tube, it's actually got a fall off, and it's actually scalloped in the other plane. And I suggested that this was a monopole pair, and that one is cutting one way and one is cutting the other, and this is the dead space between. This is the dead space between. And actually, if you actually look at this image on the front plane here, this is one of the curves, then there's a bit of the original radius, then there's another cut out here, then there's a bit of the original radius, and then there's another cut out here, and then there's a bit of the original radius, and then there's another cut out here, and then there's a bit of the original radius, and there's another cut out here, and so on around there. So I don't know, 1, 2, 3, 4, 5, maybe 6 overall structures were going around here. So you could imagine something in the middle, and maybe the intense thing that was going on in the middle ended up by producing the monopoles around the outside. It fascinated me beyond all measure when I saw that. And it was a long time before I came up with a suggestion that this monopole structure, which we know seems to be able to cut things with, it has a higher binding energy. The exotic vacuum object has a higher binding energy than any other matter. So it can basically destroy matter in ways that any other kind of process couldn't. And when you look at these monopoles on the inside of the quartz here, I've got this one here, which is you can get north and north poles collecting together. And in this case, the north pole is, when I say north, a north has in my view, it has a hole in the center. The reason is because the material's coming up from it. Whereas a south would have a white spot. So these are two south poles in my view. These are two south poles together. This is a south pole and a south pole. These might have a north pole somewhere else, but these are two south poles. And, you know, you can see that they are the same pole because there is a field interference between them where, you know, one's going that way and one's going that way. But because they interact, you get a bit of dead space in between and it doesn't damage the quartz. In this case, you have the perimeter and it sweeps the material around the perimeter here because that's where the intense cut through is of this mushroom-shaped object. You've got 3 of them together here. So this structure here is a larger magnification of this. And what you see on these structures, it sweeps around here, sweeps around here, sweeps around here, and then it comes off the end. Now, in the case of this one and this one, again, this has got this material sweeping around the end. In this case, it actually might be a south monopole, but you're looking at it from the other aspect because there is the beam coming out on the bottom. So you've got the hole there. Or it could be that I'm just, let's go back to the previous one. This spike, it's just this isn't as much rotated on the next slide. So the spike that's pushing the material or the damage out or the material coming in, it's just at a slightly different angle here. Okay. All right. Now, the interesting thing is we've shown here, where are we? We've shown here that you can have 2 together, 2 together, 2 together of the same type, 2 together of the opposite type over here. But you can also have 3 together here. Again, we know they're the same type because it's got the hole in the middle, hole in the middle, hole in the middle, and we've got the interference zone between them. Okay? We know they're the same type. So if we go to this one here, this here is a trefoil. This is a trefoil. This is 3 of the same pole together with the hole in the middle. Hole in the middle, hole in the middle, hole in the middle, and each of them has an interference zone in between, and that's because they're rotating in the same direction. So if this one's going that way and this one's going that way, this side is coming that way and this side is coming that way, so you get the interference zone here. Interference zone, interference zone. Okay? And if I go, I don't know whether I've got it on this slide. Let me see if I've got it on the slide. No, I haven't got it on the slide. I've got it in Photoshop, so let me just bring this other image up in Photoshop. Okay, so I think this is quite fun actually. I like this rather ghoulish character we've got over on here on the right. We've got this teardrop shaped eye with this kind of cartoon eyes with a bit of sort of wonky eye syndrome here, and there's teeth here. But anyway, this is a bit of fun. But anyway, here is our trefoil, and I have here a classic symbol of a trefoil. Okay, and if I just, because the glass is circular here, and it's falling away, and I'm looking at it from the outside and focusing to the inside layer, you can see the specular highlight on the smooth outside here. When I took this microscopy or this optical photography, this is the outside, this is a reflection on the outside, and this is smooth on the outside, so it's falling away. What I've done is I've just slightly distorted the trefoil, so we've got it here, so it's falling away at the same perspective as the curvature in the outside of the quartz. So if it's not clear, here is a section. And so I'm looking from the outside at the quartz, and I've got a bit of curvature on there. So I'm compensating for that curvature. And it's not just that it is an exact match for this trefoil. It is that it has the hard band on the outside. It has the band on the outside. I'll find you a classic image of a trefoil. Let me find a classic image of a trefoil. So you can go and do these searches yourself as you wish. I think the first one I want to show you is this. And this is hilarious. It's just hilarious. This is the scouting colours of Lord Baden-Powell's scouting. Right. So we have the trefoil here. If I remove my mugshot, there we go. Which is the 3-leaf of a clover, which is 2 cardioids. So this is a composite structure. And it also has the fleur-de-lis, which is your soliton ring with material being sucked in and spewed out. Okay, so we got a lot of things joining together here. It's also this kind of thing going on. And we've already seen this precise structure, by the way. So here is your kind of trefoil and your distorted trefoil. This is kind of the one that I grabbed from Wikipedia for the classic trefoil symbol. And this is a trefoil within trefoils. Okay? With your dead space, your central quiet zone in the middle. And this kind of structure here is probably something like we have, and I'll just chuck this image in there now. I'm just going to jump forward to that slide somewhere here. Oh, do I have it? Do I have it? Maybe I don't. Maybe I don't. Did I not put that in? Maybe I did. Maybe it's in a different presentation. We'll take it from a different presentation. I thought I did, but anyway. Okay. Give me a second. So, self-similar structure. Could this macro structure that we have discussed here with our 3 dividing lines and our hexagon here, could this be a trefoil of 3 trefoils? Yeah? So this is a more complex structure than the ones in Solin and this large vortex pair. Because when you look at this, it does appear to have substructure within it. So you've got a dome there, a dome there, and a dome there. Okay, and that 3 dome there is this peak here. So I believe that this is a trefoil, 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 making an overall hexagon type structure. And that is why you get this split 120 degrees. Okay. So I'll go back to where I was before. That is trefoil of trefoils. Okay. Here's the trefoil with the sweeping around. So these you will see in many, many religious structures. This is quite an interesting one. You've got a trefoil with the fleur-de-lis coming into the center. So I believe all of these structures are representations. I've said this now for nearly 4 years, over 4 years, that all of these ancient Masonic Mason structures and all of the symbols of power are, whether it be the swastika, the yin-yang, the fleur-de-lis, the trefoil, everything, all of them, all of the most important symbols of power are to do with this technology, which lies at the base of absolutely everything. Absolutely everything. Okay. All right, back to the presentation. Not that one, different one. Okay. So there's this site which I've talked about before in relation to this technology, and I have a slide in O-Day from it, and it's Skara Brae, and it's one of the oldest habitational structures in the UK, and it's in Orkney, in north of Scotland, and it's a 5,000-year-old late Stone Age village. Okay, as it's called, and you know it's got 2 circular structures with a bit that comes down. I'm sure there's no coincidence. I think they know exactly what they were doing. But outside of it, it has this structure here, and these structures, and these structures. You know, from the side, looking down. To me, this is just another group of ancient peoples, and I will probably talk about these balls at a different time. I think they are very, very important. It's no coincidence that these people made what they made. And just look at this. Just look at it. It's almost difficult to fathom. You've got a cardioid on the top here. You know, you've got counter-rotating vortices. It's not a coincidence. It's just not a coincidence. They knew about this technology. In my view, they knew about this technology. Anyway, the slide that I had in the presentation is this one. And so we will look at it there. And they have a trefoil here. And what's interesting about this trefoil is it absolutely has 3 vortices that are going around the same way. It has 3 vortices that are going around the same way. And what do we see in our trefoil here? We have 3 vortices, 3 monopole, pseudo-monopole structures, and they are going around in the same way. And as I showed you in Photoshop, that is a absolute 100% match for the accepted symbol for trefoil, and includes the hard edge. This hard edge which these structures make, where the outside of the thing interacts with material. The hard edge that interacts, the hard edge, the stiffened edge, the more intense disruption around the edge. There is no way that these people did not know that they did not know this, in my view. And so where does that leave us? Where does that leave us? Okay, so when I first saw this, I kind of thought, well, how does this work? I mean, it's like it's like 3 together. It doesn't really make any sense. But we literally have it in physical, self-organized structure, having formed on the inside of the Lion reactor from monopoles. It's there. It's there. It's there. How did they know this? Come on, tell me how they knew this. You've also, look at this structure over here. It's just amazing. You literally have this triangular section here and these 2 sections. If you look at that structure right there, look at that structure you're seeing there. In fact, and then I'm going to go back to our PSD here, but this one. I mean, is that not that? Is it not that? Is it not that? Let's go back. Is that structure there not that? Is it not? That's the same thing to me. It's the same thing. It's the same thing. I'm sorry. It's the same thing. You've got the curve and you've got the angle there. Look, the curve. Curve, 2 straight lines. Curve, 2 straight lines, right? You have this follows that line. This follows that line, right? This follows that line. This follows that line. It follows that line. It follows that line. It follows that line, kind of. It follows that line, definitely. And it kind of follows that line, right? This structure here is the same as this self-organized plasma structure here. There's no way the people on that island in 5,000 years ago, at least. I mean, the settlement is from 5,000 years ago. It's like they didn't suddenly build the whole settlement 5,000 years ago and put all this intricate carving onto these seminal stones just in a day. That came about through knowledge that was passed down from maybe thousands of generations. Maybe the people that carved those sacred symbols had no idea what they meant. Their fathers, mothers, whatever, however many generations, someone worked it out. It can't be coincidence. It can't be coincidence. It's a ceremonial religious site, and it has a trefoil there. It has the trefoil that is exactly what you see here. It's just exactly it. It's exactly it. 3 vortices going around the same way. 3 vortices going around the same way. And this structure here, where you have counter-rotating vortices, you get something else down here. And that is it. That is it right there. That is it. It's exactly that. So this means, I believe, that whoever came up with I think Tesla must have learned this from some school or whatever. And by the way, there's another cardioid over here. It's all over, and here's one of the structures with the ring. This is actually the cone under here. It's just like this particular sample, the 10 yen coin has it literally. It has it all. It has it all. Obviously, the big size scale of it as well. It also has it. Okay. Now, I'm just a couple of random slides, and then I'll get in. Cardone used sound into Mercury. Mercury does not have any water in it, but obviously aluminium is paramagnetic. Aluminium interacts with Mercury, but if you look at the interaction that occurs between these two, it produces not this particular element. This is not what I want. It produces elements that were observed. Dr. Amaza observed the production in or the radiation remediation, but he found that with pure water, I think this was in 2001, he did vibration of water, and it had no magnesium, aluminium, selenium, copper, zinc beforehand, and low levels of sodium and calcium and potassium, zero potassium. But after vibration of pure water, massive amounts of magnesium, large amounts of aluminium. This is parts per billion, but it's like this is very large increases. Okay, so you've got lots of calcium here, lots of zinc, all kinds of things. Okay. So it was replicated. This is just a vibration in water. Right. Now, this is where I've missed a week's work. And I'm just going to run through this very, very quickly, because I will do another presentation where I will be a little bit clearer on this and be more succinct. But like I say, I don't know what's going to happen right now. And so it's important that I get this out to people in a raw form. Don't let perfect be the enemy of the good. Okay. So, Cardone also saw. We've also in other experiments shown that trefoil was observed on a ultrasonically vibrated piece of steel, which was resonant, obviously, and that produced a trefoil on there. In Ultra, we've produced trefoils, and here's one of the trefoils from one of the caps, and we talked about that in the past. That this is a trefoil that was ripped off. Hutchison saw a trefoil, so there was a trefoil on the surface. Maybe I actually have that. You can see that in the image that I showed you earlier of the top. Yeah, so here's the trefoil down there. So maybe if I can't zoom into that. But anyway, there's a trefoil down here. Okay, and this trefoil we noticed was made of 3 yin-yang pairs together. Okay, so there's one there, one there, one there. Okay, so this actually has 3 cardioids in it. Okay, and interestingly, the one's above the other one's above the other one in this. Maybe I can zoom into that. I have this in different photography. Okay, so you can actually see here if I stop it in the secondary image. Where am I now? There we go. Okay, let's go here. Go pause. Right, so here, I think this one is top, this one is lower, and this one's the lowest. I'm going to try and, maybe I can zoom into that for you, just so for the sake of argument here. I've got it in better macro photography, but give me a second. See what happened there. I lost my... Okay, back in the room, give me a sec. Okay, all right, so you're going to go there, and I'm going to take this, and I'm going to make it bigger. Not that, I'm going to make that bigger. So it's going to be a bit messy. Right, there we go. Okay, so here is our trefoil. And if I can pause that, and I zoom on here, you can see that this is above, this one is below that one, and that one's at the bottom. And we saw when we looked at this with different optical imagery. And I will look at this even more now. We've got a cardioid shape here. We've got a cardioid shape here. And I believe that this has two spots, and this has two spots in there. So this is three yin-yangs that have come together. Okay. All right. And this is kind of like what you could almost call this like a swastika, but it's a 3-point swastika. And we've seen these things in other experiments, particularly in lion experiments. So maybe if I undo that and go back there. Okay, right. Right, where was I? Okay. All right, so the trefoils and all these structures seem to occur on surfaces and on that should be crystal boundaries. I'm going to correct that right now. Should be crystal boundaries. Now, why would that be? Why would these structures occur on surfaces or crystal boundaries? Well, think about what I said in Safe and Sound. If I have, I don't know, what have I got here? Lump of metal. If I have a lump of metal, let's say this is a lump of metal, and this is the air above, and this is the solid metal below, and I have sound propagating through the metal, or any vibration. It can be a thermal phonon, it can be ultrasonics, whatever. When it hits the surface, it has a reflection. So the first point at which you get a node where you can get phase conjugation is on the surface, and that is the same on the crystal boundaries. So this is where you get the charge separation, and the charge separation, as I've shown you in the eating away of the lumina in the center of the lion reactor, that is magnetic charge separation. This is not electrical charge separation, this is magnetic charge separation. So north and south pole forms in solitons, as said by Solin in his patent. It produces two solitons of different magnetic charges. And so that is essentially what you're getting. So I believe the reason we are getting effects that occur on the surface of materials, so or on crystal boundaries, like on this fracture sample here, is that it gets to the crystal boundary, and that is where the charge separation can occur. And so you get these two north and south structures, one over the other, and if the energy keeps getting resonantly pumped in, it builds and builds and builds. So this is what Matsumoto said: the effects occur on surfaces and on crystal boundaries. That's what he observed inside his palladium in 1990. It is what John Hutchison observed in late 1970s and 1980s and so forth. And obviously in that sample I just showed you from 2007, it is a surface effect. Why is it a surface effect? I believe it's because that's where you get the first node from the resonant standing waves, and you get the phase conjugation, and you get what you see going on in the nodes in this particular video that I showed you here, and you get this separation. Okay. All right, so Vladimir Vysotsky, who's unfortunately trapped in Kiev at the moment, I actually stood next to him when he was talking through his paper at ICCF 18 he had a water jet going through a water jet metal cutting device, and he showed that from the side of it he synthesized X-rays. So intense cavitation and vibration. Cavitation with a regular flow rate through a system is producing pulsed energy into a location. The pulsed energy will then produce phase conjugation, resonantly enhanced, I believe, at the surface, produces the charge separation, these yin-yang pairs, that will cause matter to disintegrate into light and leptons, and some of the light will be X-rays. And so that is what I believe is going on there. Caribou observed this before him, and when Vysotsky released this thing at ICCF 18, he was being challenged by the MIT scientist, which I forget the name of. I'm very sorry at the moment. But anyway, he's currently studying the relationship between phonons at MIT Peter, I'm going to remember his name, Peter, oh, sorry Peter, I've forgotten your name instantaneously at this moment. But anyway, Peter, he was having a debate, and I actually gave them 1,000 rupee bill, and I said, look, whoever wins, you give it to the other person. But anyway, this set Peter off on his journey to investigate sound, and I believe Caribou was doing sound. And in fact, when you have cavitation bubbles, obviously they are going to produce sound, and when you have electrolysis, you are going to have sound. So where I can show you here, this paper, where is it? This paper here, and note that some of the most effective experiments and simplest experiments of Takaaki Matsumoto were using underwater spark discharge. And also you have the Mizuno work of underwater plasma work. Then you have this paper, which is from 2009, Efficiency of Energy Conversion in Underwater Spark Discharges and Associated Bubble Oscillations, Experimental Results. And actually this is done at the Czech Technical University in Prague. So I'd like to contact this chap, Jaroslav Plotek. You can see here that it's a very simple experiment actually, and I might have a go of it myself. So they've got a high-speed camera, and they've got a point electrode and a cathode, and they are doing an explosion. And notice there's little sparks and things coming out of there. That is exactly what Matsumoto observed, and that they see a shock wave coming from that. And so there we go. So if you have cavitation, you're going to produce sound, intense sound, shock waves, and that is going to produce sound which will hit a surface. The surface can produce some phase conjugation, and therefore we have the charge separation as I've discussed before. Ta-da! All right, we can leave that one. Okay, so that's phase conjugation with underwater spark discharge. Okay, right, so Suhas Ralkar, obviously with the Echo fuel generator, he literally had 1.5 kilowatts of sound from a resonant horn opposite another 1.5 kilowatts of sound pointing at each other in phase. So if they were out of phase by 180 degrees, you would get standing waves in there. So that's kind of what I want to achieve in this, your standing waves across there. So basically he was just trying to mill material, but he synthesized and did a lot of transmutation, and the material produced a lot of strange radiation, which I will argue where that's coming from in a little while. But anyway, so Suhas Ralkar was doing it, Claytor and Stringham, I've already talked about that. And also Lion, I've talked about the fact that there was a 22 kilohertz ripple on the power supply, that was a low number of turns around a high number of turns for the copper that was wound around the inside of the fused quartz, and this led to ultrasonics, and then you had this vibration in there. And diamond is obviously extremely stiff. You don't get much stiffer than diamond, so you will have phase conjugation on the surface of the diamond, which will form the yin-yang pairs, the little ball lightnings, and they will go round and do the transmutation. Okay. Yes, Daniel, the ohm symbol is exactly a kind of cardioid. Yes, well, that's exactly the point. that's my point. You're on board. Okay, so I'm going to talk about another paper here. So I'm going to go to the paper, and then I'm just going to focus in on one image, in fact, two images. So the first image is going to be relating to what I talked about with the cone that was synthesized here. So we had our cone that was synthesized here, and we also had a cone that was synthesized here from these two sound generating devices. So I'm going to find something here similar to that, and this is in a paper which I've spoken about before, and this is called Bubble Structures in Acoustic Cavitation. So this is direct sound acoustic cavitation, and we'll just look at the pretty pictures because they've done some very nice work in here. So the first is this one. So you've got a one-dimensional filament coming down. It's actually This is from the top, so you can get... This actually has material coming in from the outside to a central focal point, and you see this exact same thing occurring in EVOs, where the EVOs come from at the outside of material and then cluster to a central point, and that's in some of the work by Ken Shoulders. So these are some other structures here. We'll come back to that one. So here's, you've got two opposite each other, and this is in the water column. So you have a focal point here and a focal point here, and they have some relationship between the two, and we're going to look at something similar to that. And here is a very, very clear example of this conical structure that's forming from the sonicator. So this is quite similar, but it's clearer represented to what I showed you in the other two examples before, one in air and one with a vapor in air, and one underwater. You can see this cone, and it comes down to this filament. And so this is what I believe is occurring, and for some reason you're getting the yin-yang pairs occurring sometimes down the side of the cone, and then the first one occurs at the central point here, and this is under sort of maybe a higher time thing. And I think you're getting a vortex here, and it's essentially, I believe, that what causes a bit of cymatics on a flat plate is actually driving things to kind of the center, which is the point of maximum energy, which pushes this down, and so you end up with this kind of conical structure that will form. I'm going to talk about this with a very, very different technology, and how I believe it explains a very, very different technology, and I've been wanting to talk about that for many, many years, but understanding what you're seeing here will really, really help you, and it's a very, very key technology people want to know about. So you can look forward to that. But what I want to go back to is this image up here. Where is it? Where is it? Where is it? Up here. This one. Because you have what looks like two spots here, but it doesn't matter. You've got things coming around, so you have something coming out that way and something coming out that way, right? So there's something here which is seemingly pulling things in this way, and you have something here which seemingly pulling things in this way, okay? But they then have a relationship between the two. So if you can imagine, this is transverse, it's pulling stuff in there, and so this here would be our yin-yang pair. There's something that's pulling stuff away from the environment, and it's also sharing something out of the top. It's pulling stuff from the environment at the tangent, and it's sharing stuff between the two. Okay, so you've got a relationship between the yin and the yang, and you've got the cohering from the environment. So this is again the tangent to it. This is the tangent to it. So I believe that this type of structure might explain the observations you are seeing here, but also the observations you are seeing here, where you have something at a tangent and something at a tangent. And if we go back through this video, you will see when there's material coming in, I imagine that something similar is going on with these planes. And you've got something coming around here and then going in at a tangent. But you've also got material shared continuously between the two. Okay? Things coming in at a tangent, and that's because I believe you have a vortex here, and you have a counter vortex here, and you have the sharing between the two. In this case, I want you to look at this very closely. So I'm going to go back to the presentation, because it's in the presentation where I have the major structure here. And I've just accentuated it, okay, slightly by contrast adjustment. Okay, so here it is. Vortex pairs in a ultrasonic tank. Okay, so I believe that this is what I'm calling them. So I believe that this is a perspective issue. I think this one is rotating one way and this one's actually rotating the other way, but it's kind of like a perspective issue. Okay, so they do look like they're both rotating the same way, and we do know that they can interact in the same way. We've seen it in Lion, and we've seen it in this particularly. So if I show you this, you can see these are rotating the same way. At least it would appear from this perspective. Okay, so anyway, my point is more on the relationship between the two and how we've seen that in other systems. So Firstly, it looks like it has a spherical or circular section in the middle, and then these spiral arms that come off. Spherical section in the middle, and then spiral arms that come off. But more importantly, it appears that out of the orthogonal area, there is a vortex structure coming out here. Okay? And out of this orthogonal to this spinning plane, perpendicular. Is that perpendicular? Perpendicular. Yeah, perpendicular to the spinning plane, you have a helical structure coming out, and you can see a line there, a line there, and a line there. Here you can see it. So this is it going around that way, and then is this one going around that way? It looks like they're going around counter-rotating. So I believe that these two structures are the bits that's coming in from the environment. So this is coming down, and this is coming up, and then there's the sharing of the material between the two. Okay, so that might not be so clear, but anyway. And then I have this image from a Mars vibrator steel plates. This, I believe, is one of them's a counter-rotating vortex, and the other one's the same vortex. This is probably the same because you've got interference, maybe, or this is on top of this one. But anyway, you get the idea. But very similar to this vortical beam coming out here and this vortical beam coming out here, you have this video which I shared you have this video here, which I've got two still frames from, when I changed the polarization. This is one vortex, and out of the vortex, from the center, you have this helical structure coming out to another vortex. This one's coming out here and going down to this one, okay? And I have a close-up of it here. It comes out, the helical sections to the center of this other spot up here. So I believe that material is cohered down, and then it comes out in a beam, and I think that is consistent between that and what we are seeing here. There's a vortex here, and out of the pole you've got material coming out. There's a vortex here, and out of the pole that is coming out, but this is going kind of like out this way and in here maybe, and this one's coming out there and in here. Okay, so I think they're feeding each other. And we saw this, I talked about this earlier, the vortex. Now, a number of weeks ago, I said something that I'd seen the very first time when I saw this back in 2020, I think, or in the experiment of Henk Vega experiment. And I asked people to think about what it was. It stumped me for quite a bit of time as to what might be going on. But now I believe that we have it sorted, actually, what's going on. And it is this. This is from the first experiment that I was talking about up the top here. This one. So I've taken a close-up of it, of one of these pairs, okay? One of these pairs. So that's that. So this is at the node, okay? And this is a contrast-adjusted self-organized plasma hemisphere on the tungsten wire in the Vega experiment of Henk. And I asked a number of moons ago, what are these two spots on here? What are these two spots? What is these two spots? What are these two spots, which seem to be pointing to a point up here, a common space up here? Why are there only two spots? Why are there only two spots on each of these things? Why are there not more spots? These ones you can only see one, but you can imagine that the opposite one would be on the other side. And I believe what you're seeing here is the magnetic charge separation in this structure. Okay? And I believe that's the same thing that you're seeing here in this sound analog. You have an intensity here and an intensity here. And if you made this overall structure much, much bigger, you would observe something like this. A circular section, a spherical section in the thing, or a toroidal section rather, that's doing its toroidal and poloidal motion. It's causing these vortex of bubbles to come in, and somehow out of its pole putting these ejections, these helical ejections, okay? and this is a center of one of those, and you have a helix in the vortical structure of the cardioid structure, which this is optical microscopy, this is scanning electron microscopy with element magnification. So, and I haven't got it for you today, and I wanted to get it for you today, and I will dig it out. But what I did is I took one of these self-developing X-rays. I took some of this self-adhesive foil, and I stuck it on the front face of this self-developing X-ray. Okay, and then I developed it into an X-ray, and then I looked at the X-ray, and on the X-ray, I can tell you, I can't find it right now, but there was almost an identical structure to this, which was 100 microns in diameter. Okay, the same scale as the sort of structure that was found on the Claytor Stringham work, and it had two circular structures with beams coming between them. Very kind of not quite like this, but it looked more like this, and it looked more like this, with this sort of cloud going between them. Okay, so for whatever reason, I believe that this is a hydrodynamic, probably leading to magnetohydrodynamic equivalent of this structure that we see in the plasma. And I have shown that these yin-yang pairs can group into 3, but they can group into more than that, actually. And we know that from studies that are done in the Lafferty book. But anyway, I won't go into that, it's in the cupboard. But you're saying, well, could this work on every scale? Well, I argue it could. And I will share this image that I shared from many moons ago in another plasma system called Jupiter. Here we have Jupiter. And if you look at this, there seems to be 1, 2, 3, 4 structures, which are very similar, and they have a very intense core in the center. Very intense core, very intense core, very intense core. These ones look a little bit wishy-washy. Wishy-washy, not quite as intense as the ones either side. I believe that these are opposite poles. These are opposite poles. Okay? Da-da-da-da-da. Right? So I believe literally what you are seeing here is maybe this is one's the yin, one's the yang, but they are forming magnetic structure. And I guess, well, I don't know whether this is the North Pole. So this would be the North Pole, so it's ejecting stuff. So I imagine, because this is dark in the center, I imagine that this is north, this is a south, this is north, this is a south, this is north, this is south, this is north, this is south. Okay, there we go. Isn't it lovely? And this would be like the equivalent of a 4-leaf clover. And these two structures together would make a cardioid. You've got cardioid, 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 cardioid. And they are going up to the central spot. And I will talk about... Now, I don't know whether I'm going to do the one about what the sonicator implies, or another one which will be talking about ancient archaeology. I don't know which I want to do more next week, and maybe you'll give me a decision as to what you think I should be doing. But this, I believe, works on all scales. I have a build here. I don't even know what it does. What does it do? Oh, yes, okay. So I've put this vortical structure. This was from Triangles and Spirals presentation. So you can see the vortex going in there. Okay. All right. Now, where have we seen these vortexes before? Well, we have seen it here. And this is the peak on the left. And this is the trough on the right. Okay. And you can see I'm zoomed into this peak because it's not quite so obvious. This peak has the vortex going around this way. So this is rotating to the right as I'm rotating here. This one has the spiral arms coming out there, and this is rotating to the left. And note that it has a more spherical section or hexagonal section in the center with the two arms coming out. This is almost exactly the same as our spherical section here with the two arms coming out. Spherical section with the two arms coming out. Okay? Spherical section, two arms coming out. We don't see the second arm on here. It's not very clear. We see mostly just this one. Now, the interesting thing is, I don't know whether people remember, and I can, in the blog I will actually put this, but from memory, this is boron. This is boron, which is lighter than the oxygen in the water, and it's lighter than the aluminium you have here, and lighter than the carbon that seems to be synthesized here. Okay? And over this side, if you recall, I believe we have silver round here. Okay? So I would suggest that this side here, the boron side, is the break side. It's breaking the aluminium down, the oxygen, and maybe carbon, and whatever, and it's synthesizing. It might be completely breaking the material, and it's rebirthing itself in the center of the vortex as boron. Okay? This one is the opposite way round, and in this case, it's crushing material, and so on the inside here you see the silver. Okay, now if I was to look at this from the underside, that would be a 6, and this would be effectively a 9. Okay, but you see it on a more macro level. So I don't know exactly the filament. I think there's a filament that comes out of here and down here, and then spins around like that. And then there will be a filament that comes down here around them and then spins around the other way in there, as we talked about last time. And here again in this one, you can see there's a vortical structure coming out from the bottom of this, and something's going into this, and I've zoomed in again, and that's going around clockwise on this one, and this material is coming out anti-clockwise. Now the question is this actually going in clockwise? And there's another piece of material here that comes out from the bottom of this that you can't see, that's going around the opposite direction. I don't know, but these are the vortex pairs that we see. And also, Bin Juan Huang, I talked about his work. He has an image of one of his pits, and you know, this is quite clear. It does kind of look fairly close to the structures that you see here. However, in his one, it's much clearer. So you can see the circular section in the center with the two spiral arms coming off. Circular section in the center, two spiral arms coming off. Very, very clear in his work. And in fact, when he looks at this thing around the center of the pit, you see an increase in carbon. Okay, and he's got it again on a pit here. You see this increase in carbon and also silicon. And of course, in his experiment here, he didn't have silicon, but the silicon can be made by fusing carbon and oxygen together. So take 12 and 14, is it 12 and 16 rather? And that gives you 28. So there we go, you get silicon from that. So that's what he observed. But he has this structure which is very, very, very similar. Okay, so we've got a couple of observations here that are very key. We have counter-rotating vortices. We have material that appears to be broken and potentially regenerated here, so electronuclear collapse and regeneration. And this is fusion going on in here. So we've got one that's a make and a break, okay? And that is that. And then I don't need to do that slide, so we're going to do this side. So I spoke about this on Takaaki Matsumoto's work, and he actually has some straight yin-yangs here, the cardioid structures, and he also has a trefoil down here, and we'll look at those in a little bit closer detail. But the first thing I want to talk about, and I mentioned this before, is this structure here. So these are two figure of eights, but in this case, which is essentially, I go back, I've rotated it, it's this section over here, I think it's that section, or maybe it's a different one. I think it might, maybe it's the same one. But anyway, what you have is, you have something coming out of the top of this and coming over and round. something coming out of the center of this one and coming out and round and coming into this one. This, I believe, is the same, and this may actually be twisting in its own way. I believe that this is what's going on in here. The vortex goes in and something comes out of the center in the vortex direction, and it's the opposite direction down here, and that is what feeds the other one. I don't know whether that's very clear to you guys, but yeah, it's coming out of the center here, coming round and in there. And so this is what I believe we are seeing when I go into our previous presentation, which was safe and sound. And I think we've maybe got a pretty clear idea of what's going on here. Okay, so this is the eye, and I believe possibly what's coming out of the top of the pit in the top of the cone here is something that's coming out, and it's helically coming round. So which it's going around that way, and it's coming around into a vortex here. So it's a vortex of vortex. Okay. And so this is equivalent to the structure that we saw in that other paper, and it's coming down. It will do something in the center here and do the opposite when it comes out here. Now, in light of all this understanding, I believe that probably these pairs here of something which looks similar might actually be a vortex pair, but you're looking at the one that is in front of this one, and you're just seeing the influence here of the one that's on top, if you know what I mean. So it kind of presents itself like this because of the conical angle and the relationship between the two. If you take this and project that over here, and this is, by the way, the same as the jewel shape. This is the same as the jewel shape. Okay, this is on an X-ray. Okay, so there's one paper that I also wanted to show you, which I put into the blog in the last blog that I did, which I will get now. Because it's critical to why I decided to do that X-ray experiment to see if I could see anything with a quick look-see. So I'm going to get the blog here. And go remote view. Yeah. Okay, so, and I'll get the paper. So this paper I've talked about, it's I think from Mexico before, but essentially Fernandez here. Acoustically driven X-ray emission and matter collapse in lead. So this is, yeah, in Mexico, and they produce these X-ray images, and they use these lead foils. Okay, and you can see that the lead foils were placed in something very similar to where was it? Very similar apparatus to something that I might have done here. So they've actually got this self-developing X-ray here, and they created this structure which they put the lead foil in, and they've had a little window here, and they had this acoustic shockwave generator. So my view was, I'm not able to create pulses of intense sound that are focused on a point. What I'm relying on is the self-organizing structure to focus and cause the matter collapse. And in their experiment, actually, they had the foil and the sound coming this way, parallel to, orthogonal to the lead foil. So this is equivalent to hitting the lead foil and coming back as a phase conjugated wave. But of course, they're focusing it. So if you actually look at their image, where is it? Their image of their apparatus. Where is it? The image on their apparatus. Okay, so if you have phase conjugation from here, it comes back to there. If you have phase conjugation from here, it comes back to there. If you have phase conjugation from here, it comes back to there. If you have phase conjugation, so this is focusing to the point. So, you know, depending on the size of the focus point is where you're going to get your reflection. But, you know, you would think it would come straight back. But they say by the time it gets there, it's essentially parallel. That's their diagram. But what happens is a chunk of material disappears. It disappears. It disappears. And behind that hole that gets produced in the lead, they get X-rays formed. So the acoustic pulses are coming down here to the lead foil, and they produce X-rays. And the X-rays give a very clear impression on here. And what is this? This is high energy, light. And so the matter has been collapsed to light. Like I was talking about earlier, 2 electron and a positron coming together, bang, they are converting to light. This is sound converting matter to light. And so that was my hypothesis that I was working on when I tried this. And I can't find that image for you today because I lost a bit of time during the week and it's not there. But you'll get to see it properly in the blog. Okay, so basically I think it's coming out of the top and feeding in, and something will be coming out of the center here and feeding in. Returning to this image, which was something from the exposed polymer to echo fuel. This was exposed at a distance in 2017, and I believe what you're seeing here is this bigger circle and slightly smaller circle, bigger circle and slightly smaller circle, and so forth. These are these yin-yang pairs that I've got trapped on the surface. In this case, you've got one, and this pair, part of one of the pairs has rotated slightly. Okay, so this is, I believe, the same thing. And here's some close-ups of these structures. And let's have a look. So I've got another slide here. And again, you can see on this one, out of the center, the hole in the center of this, you've got something coming out and going around this one. Okay. So I believe that is what's going on here. Remember we were talking about earlier? It comes down to the center or whatever, and then this comes out and goes around here. So I believe that this is coming out exactly as we hypothesized in the previous presentation. And there's something, this is the overall structure, and Matsumoto talks about these, he calls them like induction eddies, and when you look into eddies, the eddies have these counter-rotating vortices, and yeah, obviously it's a magnetic and electric effect, and so it's not surprising that this occurs. This is actually a lead torus, and on the outside, the lead torus has tori on the outside that are producing trefoils and these cardioid structures. And out of the center of this hexagonal bit, which we see in our ultra experiments, you have something coming out and round. Out of the center of this hexagonal structure, on the this side of this structure, you've got something coming out and coming round. Okay, so I believe that this is exactly how it works, and I think that this explains this structure. This is due to one of these magnetic monopole pairs, charge separation. I think it's because of the conical spiral beam that comes out either in or out from one or other side. You are seeing this thing. I think the strange radiation is coming from, how should we put it? Let me go back. That's the wrong one. Here. I think if we go back to the slide up here, I said the strange radiation was coming out of the center of the vortex here in 2019 and going over to this one. And I believe that is exactly what's going on. And I believe that is what is observed coming out of here and coming out of here. And this has got the chirality that way, and it's got the chirality that way. And so these spheres with the curved sections on them, I believe are mirrored in our experiment here in ultra, and it's mirrored by Benjamin Huang. And the coherence forces are sufficient to desynthesize matter and resynthesize it and force synthesis. So in LENR, one of the most inexplicable things is that you can take whatever element and you sometimes get elements above and below. And it's like, what's going on? You're getting both. And if you take a range of ingredients, it would appear that if you take heavy elements and light elements, like they did with alchemy, they would take like potassium and calcium. They would take saltpeter, for instance, that they got from wood. Potash rather, that they got from wood. Burning the ash and then getting the potassium-rich material from that. They would take that and bismuth or quicksilver, mercury or lead, and if you do the interactions, the averaging interactions, if you had a system that wanted to balance the nucleons between the two, those produce a range of elements in between if you do the reaction tables, but those elements are the elements that are most likely to produce gold as a proportion. And I have said that the focus that you would need to do to actually produce gold would be some level of cooking recipe. So you would have a certain temperature and a certain length of baking, because if you bake it too much, then you might end up with something that's all tin, for instance, in which you don't want. Yeah, so you bake it for a certain thing, but you might choose to put a certain frequency of sound in there. Now, whether that is vibration at the thermal temperature, so you had a specific thermal temperature which produces vibrations that produces the yin-yangs that are predisposed to synthesizing gold or any other element you chose, regardless. What the alchemists used were the elements that most likely to produce the highest proportion of gold. It would still only be a small proportion, but then it comes down to resonance. And I believe that, I think with studying the Ultra system, it's so simple. Whereas all of these other systems, so for instance, in the case of Hutchison, we don't know what's going to occur where, because it's a little bit approximate. It's a little bit approximate. We know we can make carbon and smash things up. We know we can make silicon and oxygen, but it's kind of like not targeting it very precisely. The plasma in the Nova reactor, yes, we can make iron, and lots of systems seem to make iron, but it's very, very dynamic. How can we ensure that we get what we want? In this system, it seems to be easy to make carbon, but it isn't, without understanding this relationship between the yin and the yang, and that this is a fundamental structure in nature. This is the maker of everything. This is the Om. It can take, as I said, in my view, it can take the energy directly from the physical vacuum, be that light bosons or be that photon bosons, and it can grab that material from the ether, and it can pull it in and synthesize it. So this is the material from the environment that gets pulled in, okay, on the tangent to the structure, let's say. It gets pulled in, okay. Where are we? This one here, and this one here. So it disassembles matter and then evens it out, or it grabs matter and synthesizes matter. It grabs matter and it synthesizes and balances it out. Okay, so there we go. So I think that's mostly where I want to be with this. I'm going to have a look at some of your comments and see what we want to, if there's anything I can add to it based on what you think. So the one they knew at Skara Brae, yes, they knew this. Before 5,000 years ago, they knew how this technology worked. The light bubbles are gaping open magnetic mouths. Yes, they are, but one is a maker and one is a breaker. One is tears matter apart, and it might be because the intense vortex Like matter is what, it's all left-handed or whatever, and it might be that left-handed makes more matter, i.e. in more dense matter, and right-handed destroys matter. So you can think of almost like a positron and an electron. Most matter is like electrons, but if you have a positron and it interacts with an electron, it'll make it into 2 photons. Okay, so by working the system in a certain way and feeding it things, either light, sound, thermal energy, matter of different types, you can, or even leaving it in free space and spinning the vortex in space, it will manifest real matter out of, let's say, relic neutrinos, which will be a flux because they are influenced by electrons. You can create a torsion field in them, and that in itself, it may actually be the means by which magnetism occurs, and that may be related to gravity, as I've discussed before. So tooth cavities appear in twos, the phase conjugate of tooth cardioid. Yeah, it probably is something like that. I wouldn't be surprised. Okay, what is this technology called? What is this technology called? I would call it O. I would call it O. What is O? O is nature. It's nature. That's what it is. And if it's all nature, well then I've called it the God's toolbox because of what it could do. And if you knew how to do those things, you could pretend that you were a god. But ultimately, if it is the source of everything, and it is able to balance everything, then it is God. We are built in its image. We are literally, you know, this is one side, and this is the shape. This right here, look at it. It's not perfect, but that right there is the shape. It's the shape of one half. It's the shape of one half. You know, I don't know. I'm gonna pick this. Look, there we go. Right. It's the ear and the eye. It's the ear and the eye. The ear and the eye. This is an ear. This is an ear. It's even got the lobe down there. This is an ear, but it's also the eye. This is the eye, as I've shown you. The way the vortexes work, it's the eye of Horus, right? And you have a left, a right, and a right ear. You have a left ovary and a right ovary. You have a left testicle and a right testicle. You have everything in nature has either a monopole structure to it, like a conch shell, or it has a dipole structure to it. It's got symmetry, right? That's it. That's nature. This is the pattern of the universe, and fundamentally, it's vortexes and vortex pairs, and between them they create everything. And I believe that by doing sound experiments, the angular frequency will produce a set of parameters that produce relatively predictable outcomes. And I think what I would like to do is have a scanning electron microscope and be able to run hundreds and hundreds and hundreds of tests with different thicknesses of different metals and different frequencies of ultrasound and different maybe reagents in there. So if I put ions in of a particular element, you know, cesium in there, or I put potassium in there, what run time or what energy of ultrasound, what level, you know, there's a number of parameters. But for the first time, we've got a experiment that is so simple a 5-year-old can do it from beginning to end, including instruction in 20 minutes. And it will, in my view, synthesize the matter at these vortices, both construction and deconstruction, giving you elements either side of where you started from, or the materials that within the materials that you give it. So as I said, it's the Father, Holy Ghost, Father, the Son, and the Holy Ghost. This is the mother. You know, one of the yings is, you know, what came first, the chicken and the egg? Well, I would argue that, you know, matter had to come first, and it had to come from something. Well, source is the Holy Spirit. It is, let's say, it is the ether, but it is constructed ether at some level, and it you know, and it's vibration, and so the what comes in to the constructor, the maker, and the breaker is possibly relic neutrinos. This is what is available at every point in the universe. There will be denser fluxes in it coming out of magnetic structures like planets and suns. So there will be denser fluxes around structures which are able to attract this material. And I've argued that gravity possibly is where living matter is sucking this material in and constructing it, and it produces a low pressure which forces material to be attracted to it. So it's kind of like, is that gravity? It's kind of like the pressure's the same everywhere, but a gravitational well is where it's falling down into something and it's being condensed. It's being condensed, and it emits light because it's condensing matter in a way. It's not just light reflecting off it. It's light is being absorbed, and so is things that you can't see, and it's still then releasing light. So there's an interchange there. So let me just go here, and I'm going to see your notes. Okay. Is Bob making light of the subject? I think you're trying to be funny, Rhett. No, I think this is all that there is, and it is the thing that will enable anything. As Ken Shoulders says, if you thought of something that you would like to do well, this is probably the thing that would do it best, and because it is the maker, it's the breaker, it's the thing that can go fastest. It's the thing that whatever you want. I think he called it the universal clutch, and I riffed on that with my original Russian conference presentation called the Monopole clutch, because I realized that it's two monopoles, pseudo-monopoles created by ether vortex, and that's. It's literally mind-blowingly amazing. It's been a real pleasure and a deep honor and a huge responsibility to have been given the opportunity to work with so many scientists. And I have to thank all of the donors. I mean, just immeasurable number of donors that have made this work possible. And I don't just mean in financial terms. I mean those people that have gone, oh, I think there's something interesting there. Because, for instance, that paper that I showed you about the matter collapse, that was shared with me by someone who thought, well, this looks interesting. And so, it's that contributions across the board, and also sharing the message, really. But it's easy. When I first sort of started to come to terms with this, I thought it just couldn't be that simple. It literally couldn't be that simple, but it appears to be. And it's kind of like when you understand it, everything else becomes so easy, really, really easy. And it's like you can move forward with confidence, knowing that whatever is presented will always do this. It will always do it. So, for me to see these things here in 2017, I knew that this was incredibly significant. I didn't really know why, right? And this is on one Lion 1 quartz inside of the reactor, and this is a reactor that's been taken out, it's turned off, and it's put next to something like those X-ray films, and you get the identical structure. And the shape of this is the shape of the jewel. The bizarre thing about the jewel itself is, if I can find it, it's not in this presentation, is it? I'm in the wrong presentation. Let me go and get it. Where is it? I've got it in a different slide. I had it here somewhere. Somewhere over the rainbow, blue eyes fly. Okay. Here, you notice it's very, very crisp on the outside here. Very, very crisp on the outside, but it's kind of fuzzy, and it has this bit coming off here, and it's kind of like not so sure about itself over here. Well, that's kind of just what we see on that other presentation. It's just in the sound. It's in the sound, like wherever it was here. It's what you're seeing here. It's very, very sure of itself around here. It's very, very sure of itself around here. Very, very sure of itself around here. But it's kind of like coming in and doing things over here. And it's sort of coming in and it's doing things here. It's like different. And so when you see that this is there and this is there, and then you see these on other systems, and then there it is. There it is. It's one half. It's one half of the system. In ultrasound, you know. Add materials as it's running in powder form. Yeah, you could put powder form in there, yeah. Ions are just as good because, you know, if you're starting with powder form, that's that is what was done by Suhas Ralkar. He added powders and then used intense sound, 4.5 kilowatts of sound, orthogonal to each other, which means everything is going to be causing phase conjugation. It's going to cause phase conjugation on, you've got a particle embedded in the water, and so the sound wave comes across the water, it hits the particle, which is like a very, 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 very small aluminium foil, let's say, right? And it's just a sheet of metal. It hits the metal, and it's gonna phase conjugate, isn't it? It's going to reflect back some of it, and when it does that, you're going to get, you know, if it's high enough frequency sound, and he was using 19.46 kilohertz, there's a lot of cycles, and if the particle gets locked at a node in some of the composite field interference, so, you know, there's one thing to say when you've got sound and reflecting back, it's like light, it's only orthogonal, or sorry, perpendicular rather, when you are opposite it, but when you are how should we put this? When you've got field interference, you've got overlapping, so you have nodes all over the place. You have literally nodes everywhere where the scalar waves, the longitudinal waves interact. You're going to have nodes all through. It's going to be a mesh of nodes in that 3D volume in that echo reactor. So it's just amazing. It's just amazing. Can you etch the material to try and control the outcome? Have the grains of the crystal structure in a fixed pattern. I will talk about a presentation that's in the release that's already been released from Matsumoto, and we've done this in the Vega experiments. If you deliberately put, you know, if you look at the stuff we shared from Amasa gas on tungsten, there were annular and some longitudinal cracks on the tungsten welding rod, and it's in those that the process initiates. And the reason is you've got some ability for the clustering to start occurring, and when the clustering occurs, then you're going to get the vortices and so on. I imagine the very big structure here had some initiation point, and all of these things are talked about by a Russian author who I've spoken about a lot of times, but I can't remember his name right now, who came up with the term ectons, and he said that cracks and crevices and points and so on, anywhere where there can be a localization of anything leading to concentration, you will end up with these things forming. So what am I trying to do? I'm trying to find the image here. So the point that I'm making is about this one. This is on the tungsten, and you can see that there are these cracks, and the cracks are where the so-called plasmoids form, and we know that the plasmoids have in them the means by which they can produce these yin-yang pairs, and I believe that is what I shared here, that this is in the sound vapor hydrodynamic system that becomes magnetohydrodynamic through charge separation that ends up with magnetic charge separation. And I believe that that is what's going on here. So this is your plasmoid, which actually is a magnetic north and south polar structure. And we showed that the big ones that form either side, when it cuts the tungsten, one fell away and it actually pointed the whole piece of tungsten with the spherical plasma ball. It actually pointed to the other one that was already still on the metal. So that was my understanding that this is one very large magnetic structure, which is not really caring about anything else going on in the reactor. And the alchemists got their results with heat to purify their substances and polarized light. Very low tech, yeah. Well, I didn't know about the polarized light, but that would make a lot of sense. Polarized light will assist the process. Hey, Bob, have you ever researched Keely? I would love to hear your take on his stuff. He seems to have been playing with these characteristics back in the 1870s. I haven't. I've heard of the thing called Keely.net. Maybe I've seen some of his stuff and I'm not recalling it immediately. But this is how it works. This is how it works. It's just how it works. It can't not be how it works. Unless there's another universe that everyone else is living in, this is how it works. And, you know, I don't know how much Tesla knew or how much Tesla was drawing on ancient texts. It's clear that if it's in Skara Brae, defined with such precise, absolute, you know, just to go back to that Skara Brae image. Here, where is it? Skara Brae. Here. The fact that here they have what is exactly what a trefoil is, which is 3 of these monopoles in the same orientation. The fact that they literally have that, and that is exactly what you see here in the trefoil on the 3 same pole pseudo-monopole structures here on the inside of one of the Lions reactors. It's nigh on impossible. And then this structure down here with the curved section at the bottom and these sections, it's like how they knew that. So this predates Tesla by many thousands of years. So as I've said, because this is how nature works, sooner or later you will come to the same conclusion. Okay, because it's going to be the solution always. There will be no other option. But the fact that you have this curve with these 2 points here, and you have this curve with these 2 points here, and then you have these kind of like rhombic sections here, which are these rhombic sections here, these rhombic sections here. And in there you have the counter-rotating vortices, these patches here, which this is a bowl, this is a bowl. Well, this is a bowl and this is a bowl. I mean, it's like, it's almost impossible that it can't be what it is. It's just that there is that. It's just is what it is. There we go. And this here is this, all rotating around the same way. Skara Brae. This is at least 5,000-year-old knowledge, and then a lot more on top of that. Search for Triskelion. That's the name of the exact pattern on the rock. Okay, all right. I will look into that. Okay. Stephen Hall's Lightbringer probably refers to this physics. Well, I know Lightbringer is something to do with Masonics. Like I say, my father was an extremely senior Mason. I will talk about my mother's bloodline and the stories in the family of why they were brought together and some things that were looked out by the Masons to bring them together, which is all a bit weird. And where I've talked about where I had to bury my grandmother in the past and the significance of that. You know, I knew I had to do this job from about the age of 4 or 6. and I knew it would be in my 40s, and I'm 50 in September the 23rd. So when I knew there was a risk to me not being able to share this, I thought I kind of like had to get this out this week, and you know, it's been all of my 40s, literally all of my 40s, and so I kind of just want to talk about more move ahead with the implications of it, and do the finessing on the research, so it's just like even anyone can accept it. So that's kind of where I want to go, but every time I think my job here is done, I realize that there's so much more. I mean, as I said in Aarhus a number of years ago, that there will be whole universities that are dedicated, many different departments, to aspects of this technology, and it'll be thousands of years of leveraging what it means, because you're literally able to make and destroy matter and transmute between matter. It is the power of the gods. It's the power of the gods, and it's very sobering. I'm going to talk about some myths which might have a direct correlation to this, but I'm going to do some short presentations on those. So Wildman, so this is D2105K. Wildman, the original stained glass in Gothic cathedrals was made by alchemists. Well, there you go. And reputed to emit more light than was striking it from the outside. Well, that would be interesting. Modern stained glass is just ordinarily coloured. Yeah, I do know that there was a lot of understanding of nanoparticles in coloured glass technologies, going back to Greeks and Romans and so on. And for instance, if you have nano gold, that will, when you have nanoparticles close to each other, they will cause an energy concentration, and one would imagine that could cause coherence. And if that does, then if you've got matter coherence, then the glass itself will be emitting light. There we go. So, like, it's almost, like I say, it becomes too easy. It becomes too easy to understand things which should be really complicated, but they're not. It's all the same thing. It's literally all the same thing. Yeah, I was going to mention about fluids going down a funnel. I mean, it's like, you know, pull the plug out of your drain and the water goes down in a vortex, and that's it. And if you think about a vortex, when it gets to its tip, you've got one atom that wants to go that way and that way at the same time, and that means it can't go anywhere, which means it's going to have to cohere. It's like there is a coherence point in a vortex. So, you know, is that what you're seeing? Is that the root of it all? Do spiral staircases produce radio signals? Maybe. Ben Hyde Spark site. I'll upload them to my Facebook. Okay. Yes, David. It's Hegelstein, Peter Hegelstein. So He was in a debate, and I actually have it. I've recorded the audio, or I've got it on video. Their debate at ICCF 18 in Missouri, and they were debating these X-rays that were being emitted from this ultrasonic device. And I believe the whole thing is sound. The whole thing is sound, or rather, it's vibration, and sound is a good way to get to vibration. It doesn't matter whether you are using vibration in the terms of phonons, like matter vibration, like heat, or you are taking a piezo device and converting that into phonons or matter vibration that's at the frequency of, say, a microwave, using the piezo system, which I suggested when I visited the Hutchison lab based on work in the 1950s and 60s, and then it came out in the Salvatore Paya patents as a means to achieve room temperature, etc., superconductivity. And for room temperature superconductivity, you have to cohere the electrons into Cooper pairs and so forth, and then make that through the whole body. So I believe that that is what it would do. And I think that's what's happening in the Vega Valley to a large extent. And the Vega Valley coherent fluidized electrons is just a whole load of north-south vortex pairs, and that's why you have those green and those red bands, which are the same scale as the pairs of cones. So it's 200 microns or whatever it is across two cones, and the green and red are 200 microns across, or whatever it is. It's the same scale, and it is the same vortical structure that is producing that polarized, alternately polarized things, and it is magnetic because intense magnetism leads to polarization of light. I just created a lopsided trefoil a moment ago with my setup. Would you like to see the pics? Yes, I'd love to see them. Okay, it's nearly 2 o'clock for me here, so I'm probably going to call it a night. So, like I say, I would have liked to... So this is interesting because Dan Winter, I get a sense that he sees many of these same patterns, I'm sure. The tip at the end of the vortex represents where transverse waves go through a singularity and become longitudinal. Yeah, that may well be the case. Certainly, you've already got longitudinal waves when you're using sound. So the interesting thing is that you're getting sound, and at the point of coherence of the sound, you are getting charge separation, but in this case I believe it's magnetic charge separation. But then you're seeing that in the plasma. Of course, in the plasma, in the Vega systems, that has also got vibration in there. You've got mains hum, which is 50 hertz, and there might be a lot to do with 50 hertz. I would be interested to see if systems in plasma have different scales of the plasma structures, depending on whether you're in the States or whether you're in Europe. That would be interesting in its own right. Okay, so I didn't know that Dan Winter had attached him angular frequency, but that is it. And so my point on that was, if we go back to that slide, was Tesla had a lot of quirks, and he would walk 3 times around a block before entering the building. And I only read that quote last night for the first time. I had no idea he did that, actually. No idea whatsoever. But I believe that he was sending a message, and I don't believe he originated that message. As I've shown you, the information is on the Skara Brae stone, okay, from 5,000 years ago. So he got that information either because the universe was giving it to him, or because he had seen the pattern of the universe and it became obvious, which was my experience, or whatever. But he wanted to pass that information forward by showing a quirk that would reveal that he knew something more. And so he was walking around the block 3 times before entering. So that is a velocity of his walking, but angular because he's rotating around the building. And that for me is the angular velocity, and that leads to the production of the magnetic charge separation, which leads to the ability to make, destroy, remake, transmute matter. So just to quickly run through, very, very quickly, this was our opening slide. I loved this because it had the 69 on the image, and I always thought that that would become important one day. It also had these scallop sections out here, which I knew I needed to find an explanation for, because this is alumina and it was melting at over 1,000 degrees centigrade above the temperature of the reactor's normal temperature running. And the joule was something of the most amazing part of the whole Lion experience, because this had to be explained. And when I found out that it was the interaction of X-rays with quartz and heated to the at least the temperature that this reactor did, that would produce this dual thing color, then it had to be X-rays. And Ken Shoulders said that EVOs can produce X-rays, and I think we can understand that it's doing that by collapsing matter, and that produces the X-rays. And we've seen that in the Mexican study, and I believe that I've replicated that using an ultra experiment. But unfortunately, I couldn't find the image for you today. But anyway, someone else can do that before me. It's just not important anymore. It's the way it works. So, and the event horizon here was always so critical to me. So one of my O-Day slides, 83. This is the same thing as Tesla, the image that I just showed you, and he's causing the left-right vortex, and this produces your soliton, and you're cohering it with the Om sound and so forth. And I talked about this in the previous presentation. That led me to show you for the first time how the Om symbol relates to the structure, and that this is the spirit comes in here, or the matter. They can deconstruct matter. It's kind of deconstructing matter here, and it's balancing matter here. So this is this is God. This is the maker of everything. This is the Om, and it is due to angular frequency, and it can both make and destroy and remake. So it is basically the universe in a nutshell. And so whoever came up with the Om symbol knew exactly how things work. And from looking at what happened in ultrasonic tanks, it looks like something was coming out of the top of the dimple in the cone and feeding round in this ear shape, of which is part of the human physiology, and it produces a left-right structure. So this is the mouth where all food goes into the body, and this is the left and right eye. This is the mouth where all the food goes into the body, left and right eye. One side is the ear. The same thing is the nasal cavity. So the nasal cavity is this shape. You are mirrored in all form of your body, and those creatures that are more monopole like snails and so forth, and conches and stuff, they are still playing to the same structure that this is everywhere in nature. So it is the spiral, and the spiral has in it embedded the triangle, and the destruction on the Hutchison material is, in my opinion, only possible with monopoles. We see the monopole is softer in aluminium, and it's softer in softer materials, but in hard materials like quartz in this Lion section here, it's harder, and it's harder here in the iron. Okay, so in my view, it is this structure. There's two of them. They form these monopole pairs that both look essentially exactly the same. And Bogdanovich and Perovozchikov and Shishkin and Roitskev, they've all seen these structures. And this is, you might say that this is the kind of Holy Spirit up here that's coming in, and Ka here is the symbol for the spirit. This is a libation disc, maybe as much as 12,000 years ago. It's in the Metropolitan Museum, and you take the spirit and you cohere it, and then you pour it, and so this is either your beam coming out, or from my view, this is the kind of magnetic beam that comes out, and this can interact with matter in weird ways. And so this is kind of like a cross section across a surface. This is our aluminium surface, but in this case this is the surface of steel. This is 40 microns across. This is the helical vortex coming in, which will produce a triangle. There will be the opposite on the other side, and this is from 2007, from 1986, I think, and this is 4 centimeters across, so this is 40 microns, 4 centimeters across. So it's impossible that John Hutchison could create these structures deliberately. This is the vortex that comes from a monopole structure. That's what it is, and just people need to accept that, in my view. And this is nothing that I came up with originally. Tom Bearden, who died this month, he suggested it was monopoles in the 1980s, or not. It was magnetic structures that had a suppressed pole, and that's apparently, it appears, exactly what they are. And so this is the same kind of triangle on a much bigger scale to here. So there is no limit to the size at which these structures can grow. This is on video from the Moscow Nuclear Physics Laboratory, and this is the same over here. And this is one pole, but they form pairs in the Yin-Yang pair that I've discussed here. And there's a trefoil down here whilst we're here. This is our monopole here, and this is our Yin-Yang pair. And this is a monopole, and it's similar to the monopole that you see here in this coherent matter Bose-Einstein condensate experiment from this paper here. And then we showed in the sound experiments how ultrasound can produce these separation in these structures, and then this is again separation, but these are rotating in the same way, and we know this can happen, and there's a whole bunch of slides there, and I won't play that again. This was a ball lightning that struck the inside of a nova reactor, and again you have the big circle and the small circle, and this will be because it's that same structure, and that's the pattern that a ball lightning will make, and it is the same thing. These are from the nova experiment, and it showed that you had a north and a south and a yin-yang, and it synthesized these iron-rich crenellated spheres, and one was a breaker, so it synthesized carbon. And in our yin-yang on our Bullburn sample, we saw the pit, and in the pit we have a whole bunch of carbon and almost no iron, and on the top of the maker we have more iron. Carbon's there obviously because it's got slammed down on the surface from the breaker, and so forth, but that's the difference between that. This is a monopole, so we have our lead source material that's in our it's captured into our monopole, and it's ejecting carbon in the Matsumoto work. And this is one side of a monopole, but on this structure itself, on the surface of it, around this area here, you can look at the edge. This is the edge, so you've got the edge here and this bit. This is the edge, and you see these same structures on here with the peak and the trough and the overall structures here. This is the same structures all over here. So this overall structure has self-similar structures arranged all over its surface, and they are the same scale as the yin-yang pairs that are all over the surface of this Hutchison fracture surface effect surface. And that is because I believe that it doesn't like to go across the impedance mismatch between the aluminium, which is highly conductive and lots of electrons, and the air, and so the action takes place on the surface and the churning takes place on the surface. So we derive this surface, and that it feeds into vortex mathematics and cardioids, And I'd already shared many times before cardioid on Lion Jewel, cardioid on Ultra, cardioid in Parker-Myers 225 reactor, and the cardioid in Omar. And the fact that it is in these vortical cores that you get the synthesis of elements. On one side you get breaking, so you get it going from diamond outwards, and then on the other side you get making, so you get heavier elements, it would seem. And this is in Claytor and Stringham's work. So I talked about the fact that I was able with the electron gun to flip it over, and we got this structure here, but there was this spherical section at this point here. And if we looked at that, we could see here that it has this thing coming out of the center of one side of the cardioid and coming down and becoming the other side. So this is equivalent to what we've seen in other systems, and I got a close-up version here. This coming out of the center of one of the sides. And if we actually look at the other side that was flipped over in the sphere, it's synthesized calcium, and the calcium comes from carbon and silicon, which is to a certain extent already in the reactor, and we get calcium, and calcium was observed in his reactor. And that this observation of one side synthesizing calcium was also observed in a Lion reactor with this filament which had calcium. And then I went to a bunch of PSDs. Dear, I said a lot today, didn't I? And I pointed out that the cardioid structure is here in the 369 pattern, and that the cardioid is there. And you can see out of the center of this vortex side, you've got the material coming out and coming into this vortex, which is what we inferred from the video frames from the Ultra experiments here. And so then we have the exact same phenomenon occurring here on a Mars gas on tungsten, and it has this point of 9. In this case, the deconstruction here is, and the absorption of material is actually breaking down the tungsten and making carbon here. This is a carbon film, and I believe that material is being pulled into here, as well as the material that the vortex itself is balancing and producing. It's taking nitrogen and oxygen from the air, and hydrogen from the Mars gas, and oxygen from the Mars gas, and it's combining that with the tungsten and mixing those elements together in the vortex. But it's also, if sufficiently big enough, that it's able to start pulling in material from its surroundings, probably energy of any form from the ether, including relic neutrinos, but also it's able to disintegrate matter and pull that in and cohere that as well. And so we see something similar going on in ultrasonics in an Ultra experiment, except in this case it's able to pull the water in, so it doesn't do the matter destruction that we see there. And this is the structure which is identical to that on Skara Brae from the 5,000-year-old structure. So back to the main presentation. Oh dear, this is going to be a long review. Okay. All right, so that was the PSDs. And so talked about Tesla holding these two light balls, and he's doing the same thing as someone doing this, what do you call it, meditating with the left and the right hand vortices, and the fact that you have the central glow points, and you've got the whole vortex here, even with the curves on his jacket. I mean, everything about this image shows a lot of thought. I don't actually think this was a taken of him posing here. I think this was a constructed image with a lot of information in it, even down to the way that this comes out. And it is, as I said, it's ancient knowledge. But anyway, the only thing that has the binding energy to destroy this without heating it, I believe, is magnetic monopoles, and I believe that that's what did that. So that's that solved. These are monopoles with the thing firing out, and this is sweeping around. And so we talked about that, and we talked about that a bit more. And then I talked about this being the trefoil, them all being the same pole, in my view, north poles. And that this is on the Skara Brae, and they're all going around the same way. This had me confused for a real long time, and I had the answer all along, but I knew that this had to be important. And then this is the cardioid structure with the plasma vortex on the 10-yen coin. This is ultrasonics. This is ultrasonics and synthesis of matter using the Amasa vibration plates and just water. I then talked through a large number of people, which I will do probably separate presentations and split this whole presentation out. But I had one picture of a whole bunch of trefoil images that I was going to put down from various experiments. But anyway, there's these round spots with the spiral arms, and that they've from their pole they produce an intense vortex of material that comes out, and I believe that's the coherent material. These are the vortexes in the work of a Mars vibrator, and my first day there I found out of the center of one vortex there was this helical structure coming out to the center of another vortex. That's the close-up on it. So that, in my view, was the equivalent of what was observed in this other paper here. And that we know we have vortical structures, and in this case this was a breaker because we have carbon and then it goes to magnesium and then chromium around the outside in the helical structure there. And then we had these vortex pairs here in the case of the sound experiment. We had the separation there, and here in the Vega Henk experiment with these ones, which I asked people to think about, but no one gave me an answer. So this is the time I get to say what I think it is. So there we go. And I'm saying that these can work on any scale, and that on the top of Jupiter in this plasma system you have a north pole which has a dark spot, and then you have dark spot, kind of dark spot, and then wishy-washy, 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 wishy-washy. So I think that this is a north, south, north, south, north, south, north, south. This is a four-leaf clover. This is a cardioid, 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 with all pointing to the breaker, which is probably feeding their systems. So this is balancing, and this is destroying in a way. So that's that. And so there's the spiral coming in on there. And then I talked about the fact that the ultra experiment is simple. In fact, if you use lower frequency, you could get these things bigger structures, and you could maybe have a better chance of studying them. So maybe it would be better to go back to what Stringham was using early on, which was like the 24 kilohertz type transducers, rather than the 43, 46 kilohertz transducers, because you would have even more area to study the synthesis. So this has a rotation this way, clockwise, and this has a rotation anti-clockwise. This is the pit, this is the peak. In the peak you have a pit, and in the you can't see it here because it's broken up, but in the pit you have a peak. Here we saw silver and stuff, and heavier elements synthesized, and here we have a lighter element. In this case it's boron. This is lighter than the oxygen, the aluminium, and so forth in the water. And this has got heavier elements that were in the source material. In this one we have the vortex going around the right, and this one has material coming out that's going around in the vortex around to anti-clockwise. Okay, so whether this is material that's coming from out of here and going in and becoming a clockwise rotation in, or vice versa, don't know, but one's going one way, one's going the other. And the same kind of structure here with the circle in the center and the vortical arms were coming off was observed by Benjamin Huang, and he observed synthesis of silicon where there was no silicon in his water on copper. And the same structures were observed on a large Evo type metal lead structure, and we can see that out of the center of one side you have material coming out and sweeping around, and there's another example here with our one coming out and sweeping around, and again in this one coming out and sweeping around. And it's off this large structure that he had. Okay, and that is 369, or rather angular frequency leads to charge separation. Yes, the cardioid is the Mandelbrot set, or a large part of the large black spot in the Mandelbrot set is a cardioid. Yes, it's hiding in plain sight. In fact, I said a large number of years ago. In fact, it was in 2018 that I said this has to be a joke. The joke's on us, because every single symbol in ancient power symbols. And there's some slides from Ode that I will share, which are relating to this. Every single symbol is a representation of this technology. And the thing is, some people say that those symbols are there because people see those shapes in nature, and the fact that they're all representations of something that's going on in nature. So, like, you know, the helix is a shell, or the fleur de lis is a lily. All these things, but it's like, does the fleur de lis actually have a torus around it? I don't know. What really is the swastika? You know, but it's a cohering force. Everyone thinks it's going around that way, but it's not. It's cohering in, and it isn't until you see that potentially 12,000-year-old mass-produced Sumerian lantern that you see the out of coherence debossed particles coming in to the outside of the cohering swastika, and then you see them coming out of the center in phase, cohered. And the level of preciseness of the representation of the knowledge of that is mind-boggling. So this was known, and I believe it was known all over the planet prior to the last ice age, and probably for hundreds of thousands of years. So right from the beginning of 2017, I said, like, we this cannot be owned. And why I was saying it cannot be owned is because it is nature. It is effectively God, as it's everything. It's certainly the God's toolbox. It can do everything that people say God can do. So you know, we are actually built in the image of this technology. You know, the feeder, the eyes, the symmetry, the half monopoles. You know, we are built. There we go. So can fingertips near aluminium foil actually make Evo ring damage? We could see. No, but fingertips in the work of Keith Fredericks on X-ray film with a strong magnet were able to produce some of the tracks. And, you know, if I've got a particularly staticky chair here, and if I rub around on it, I'm always putting sparks onto things. Those would certainly produce tracks. So, you know, it's about, for me, I think I don't want to write a paper until I've got something really useful to write. But I think really with this ultrasonics technology, it's so simple. It has a long history of doing transmutation. And actually, to be fair, Roger Stringham has a paper where he's talking about it's cohering matter. He's got like coherent electrons but coherent deuterons, and that's causing fusion. But he's thinking it's one fusion of two deuterons, and that's producing an explosive event, and that's causing what he observes. He is actually saying that it's something to do with this nodes and antinodes and so on. But I think what we now have is a level of fidelity and coherence, to coin a word, across data sets with physical manifestations that repeat themselves over and over and over and over again, not only in the experiments, but in all we see in nature around us, and in all of the Masonic, i.e. masonry work, and religious forms. And it cannot be coincidence. It just cannot be coincidence. It can't be coincidence. Anyway, I'm going to say thank you very much. Yeah. I'm going to say thank you very much for your time and for being on this journey with me. And we're going to do some great things with this understanding. And like I say, I don't know which one I want to do first in terms of thinking about it. But I now am confident that I know what I want to do and how it works with the the ultrasonic experiment, sorry, the plasma experiment in the supernova reactor. It's been a long time, but I think I can do it safely, and I know the parameters that are important. But I want to have an SEM so I can do the experiment and see what's gone in and what's come out, and record the whole thing. I want to do that with ultrasonic, so and with replicating simple experiments of like lead wires in potassium hydroxide with a copper plate, like Matsumoto did. These experiments, they need those things coupled next to an SEM, and I would have done a good number of these experiments with Alan had I been able to travel to the US, but I still can't. And it's just utterly bonkers. And I knew they would stop at nothing. And when I say we're in a spiritual battle. We're in a spiritual battle. But we'll get through the other side of it. I'm a firm believer in that. And you guys, I challenge me. Say what you think. Say it's all a load of nonsense. But just nature does it every time. It just, it is 369. It is. Tesla was right. And it wasn't his idea. It wasn't his idea. It was nature's. It is the work of God. And everything spins in a vortex. Everything. Doesn't matter what you do, it's always spinning in a vortex. So it's the rate of spin of that vortex and the amount that you can cohere that gives you your 6 and your 9. The 3 always comes first, that omega on the side, that key part of the Om. If you don't have the Om, you can't start cohering matter from the physical vacuum. You have to have the Om first. You have to have the frequency, the angular frequency first. It's the thing you must start with. And then you can produce the cohering structure, and the cohering structure itself synthesizes matter. You drive it harder, it synthesizes heavier elements. You give it lighter elements, or you drive it too hard and you get electronuclear collapse when you get enough of them clustered together, and then it rebirths. You get effectively a supernova from electronuclear collapse. So it's a really a thing to marvel. So thank you. Yes, I honestly say I can die happy now. Really, I want to live for my children, but even to see the pattern, that is more than I could ever have hoped for in my my intellectual life. It's more than I could ever have imagined. But it's been a hard burden, and it is only made possible by you, the people that helped the journey move forward. And it's, I said when I saw the what came out of the testing with the Mars gas and metals, I said that was the end of the beginning. I think I called the presentation, that video, and I think this is another end of the beginning. But really, it was some of the stuff that happened in Japan, the immediate correlation between strange radiation and sound and synthesis of matter. Those 3 things together was the end of the beginning. But this is. It is the dawn of an old age. It is the dawn of an old age. It is eternal technology. It is the technology. And it's no one should own it. It shouldn't be patented. This is a human right. It is our right as a species. It's your right. And you made this happen. So thank you very, very much. And I wish you all to live long and prosper.